agree with you that that's not actually a correct way to get to the value of the sun. It's what you had started at the beginning. And so since we know that corpuscular rays don't actually converge on the source of the light, they tell us nothing about where the sun actually is. A sun can be 93 million miles away. And when the light comes parallel and hits that cloud finally, that's when the corpuscular phenomena begins.
Do they converge onto where the sun seems to be? Because every time I see them, my whole life, right, I'll see some corpuscular rays to my left, and I'll follow the angle they're going, and it always goes to the sun. It doesn't matter where I see them, when I see them, if they're in the sky, you just follow them. Sometimes you can only see like one, and it's at this random angle, right, coming across your screen like left to right. And you're like, okay, let me follow this, and then the clouds move a little bit, and you see those went straight to where the sun is every time. We would see little corpuscular rays because the clouds are diverting the rays all over the sky. They wouldn't give a shit about the sun. The sun is so far away, its light rays have nothing to do with what we perceive.
Well, like, they don't perceive.
Go ahead.
They're going to converge on a point that's between the two parallel ways. And by definition, that point is going to be in line with the sun. It's going to be in line with other rays of the sun, but it's not going to be anything to do with the distance to the sun.
But all the rays are parallel, right?
Correct. Well, real close to parallel.
So if there's a ray that's parallel coming straight from the sun, right, and it comes down and hits some clouds, and I see that it comes through the clouds. And if I look over to the left and I see some corpuscular rays far to the left, right, those corpuscular rays still go back to the sun, but where that light comes down far to the left over there and hits the clouds is also parallel in your model. Mm-hmm. So it comes down parallel, hits those clouds, that would cause divergence, and then they would go in different directions from there where it was obstructed. The parallel rays are way over there to the left, though. But yet, when that happens, it comes all the way back to the central point of the light source.
When you say divergence, I guess you're meaning literal divergence, but this whole time I'm thinking the illusion of divergence, like train tracks. Corpuscular rays are the illusion of parallel lines looking as if they converge or diverge, but they don't actually. It's perspective that does that.
Well, I think yes, the sun has divergent rays. But to more specifically, if the light's over there to the left, far away from the sun, the light comes down parallel, it hits the cloud, it'll divert the rays, right? And it'll appear as if it converges up to that cloud. That's all that happened.
That's not what I think is happening. That's not what I think is happening. I think what's happening is that straight parallel lines are appearing to converge or diverge because of perspective, but they aren't actually diverging.
But why wouldn't they do that over there to the left?
When you say over to the left, I don't know if I quite have the right image in my head.
Well, I'm just looking outside. I'm sitting on my front porch. I'm just looking outside, right? And so we got the sun, and then I'm looking far away from the sun over to my left in the sky. Now, there's still light in the sky. I can see parts of these clouds are more bright than the other parts of the cloud. There's still light coming in our atmosphere over here, and I can't see the sun. Now, technically, your model says that there are parallel rays that are lighting those clouds up. So when they hit those clouds, they would be able to divert. Their path would divert right there. There, strictly because of that obstruction. It came in straight. And it only altered because our perception was altered because of the obstruction that diverted the rays. That doesn't ever happen, though. That never happens.
So, quick question. Why don't we always see these rays?
Why don't we always see them?
Yeah. If the sun rays are all diverging, why don't we see them all the time?
Well, when there's nothing obstructing the sun, we do see that there's light coming from every direction off the sun.
Why don't we see them all the time when the sun is out?
The cloud is what makes them perceivable.
But we don't always see them when there are clouds out.
Yeah, sometimes the sun doesn't. Yeah, sometimes the sun doesn't get through the holes in the clouds. It just depends on the cloud.
Do get through them,
okay.
Right? They don't always.
They always converge to the sun. Yeah. Or you can show me one they don't, but it doesn't exist.
Can I ask a simple question here? If the rays that appear to be diverging were to converge at the source, the sun, above the clouds, how do they do so when you're outside the tropics where the sun never is? Say you're up in North America somewhere, and so that would mean that these rays would be converging at a point somewhere, regardless of what you want to say is their altitude, that is well above, well north of where the sun ever travels.
But you said the sun's never seen in North America.
Directly above. It only goes 23, roughly at a half degrees.
Oh,
North.
you mean directly
Okay,
overhead?
so if you're up at 30, 40, 45 degrees, do people at 45 degrees never see crepuscular rays?
If you want
Is
to,
that the case?
I don't know. I mean, if you want to show me any latitude that you're speaking of specifically where crepuscular rays didn't converge on the sun, I'd be interested to see it. But I've never seen any crepuscular rays not converge on the sun. So.
Crepuscular rays can only be seen from a point like a latitude that the sun is directly above, right? It's got to match up.
I don't know
not
that
true at
that's
all.
true. No, that's not true.
It's
I
a
live in
logical
Colorado. I
inference.
saw crepuscular
That
rays
is a
yesterday.
logical
Well, I'm in
inference of
Tennessee.
them
I saw him
converging on
yesterday.
the sun.
I'm in Tennessee. I saw him yesterday driving down the street. I
Okay,
took pictures of him. That's what
Great.
started this.
very good. Okay, so you've seen them in Tennessee, and you're saying that they converge at the sun directly above, somewhere near your location in Tennessee. Yet the sun is not above Tennessee, nor is
What?
it even close to Tennessee.
The sun wasn't close to Tennessee yesterday during the daytime when I saw the sun.
Nope.
Okay. The sun. If the sun's in my sky, and it's like this everywhere in the world, the rays in the sky will always converge onto the perceived location of the sun.
Okay, now, what's going to happen here is somebody with any desire, if they wish, and the patience to do so, to deal with this, can carry on with this. I've made my point. People either get it or they don't, and I don't really give up on. So,
Okay.
I'm done.
Well, your point was didn't do anything. So
I'll go ahead and make my point.
good.
So the pictures that you're showing us with these diverging rays, for your theory to hold, somebody on the left side of the picture would have to see the sun at a different angle than somebody on the right side of the picture. Since they're both in the same time zone, and we know they're both going to see the sun at the same angle, you have a self-contradictory idea.
Well, actually, your angle always changes relative to location.
Again, the angle is going to be the same for two people in the same time zone, like literally a couple hundred feet.
What does that mean? What does that have to do with crepuscular rays?
Well, it proves that the rays aren't diverging if they're at the
No, it
same angle.
doesn't.
Sure it does.
No, they're always converging onto the light source.
Right. They're always converging onto the light source because of perspective.
That's
But
what you
the
said.
Well, you can easily test it. You can just have somebody go to the left side of your image and somebody to the right side of your image and tell you the angle of the sun.
And they're both going to converge onto the light source.
They're both going to be the same angle. That's the point.
The light rays are always going to converge onto the light source.
Okay. So
Okay,
they're gonna
what?
both measure the sun at the same angle, which means those rays are parallel.
Are you serious?
Can I go ahead, Sam?
So
When you're done,
basically,
tell me
you've
when you finish.
conflated in red herring fallacy and diverted away to angular size.
I didn't divert to anything. All I did
Are you
was
talking about angular size?
all I did was talk about the
Alright.
facts in the ground, which is what I was trying to make a point of.
Are you saying that the sun should change the angular size?
The point? No, the point is that the angle of the sun for an observer on the left side of your image will be the same angle of the sun for an observer on the right side of your image, which means those rays are parallel.
That is
by
not
just
what that
basic
means.
geometry. Okay.
Okay.
Well, it is what it means.
No, it's
but
not.
You're a complete imbecile if you don't.
No, you
understand
just
that.
believe whatever was crafted for you. You think it makes you smart. So, if you think the sun's 93 million miles
That's
away,
how geometry
then
works. You're
no, it's not
simply
actually.
absurd
No,
at
it's
this
not
point. You have
actually.
abandoned
The way geometry
rationale.
works is you have to have an
And no
actual
one
location.
should entertain this guy that just talked over everybody the entire time.
Geometry requires an actual location. Uh-oh.
Can
Yeah.
I try?
Yeah, what? Yeah, what,
ahead.
Soundly?
Yeah, what?
Does
What?
geometry
You're-
require an
you're
actual
illustrating your
location?
Absurdity.
Does
If you have
geometry
two
require
lines that
actual
are at the
location?
same angle, they're obviously parallel.
Does geometry require an actual
By
location?
definition.
Can you not answer?
For someone who yells red herring a lot, you are really good at throwing them out when you're caught.
That's not a red herring, dumbass. This is my direct response
Just
to
got
his
painted
points.
into a corner, and every time you get
No,
painted into
I'm
a
saying
corner,
no.
all
You
do
can't
is
answer the
raise your
question,
voice
Soundly.
and
This is
yell.
why you do shit like fake images because you're a
Address my
clown show.
point.
You're a complete gammon clown show.
That is-
So
that is
anyway,
parallel lines
anyway,
by
anyway,
definition of what
does-
parallel lines
does-
are.
does geometry require actual location? Yes or no?
Negator, you're up.
Yep, you can't answer. You're a clown. You're a fucking clown. So anyone else want to answer?
Shut the fuck up.
Can you
Yeah,
answer?
Can I give this a shot?
Can you answer the question?
Can you hear me?
Can y'all
If
be
you can
nice
answer
with
the
it?
question,
Calm
that'd be
down,
great.
man. You
Look,
asked
let
for it
me-
to be recording. Like,
Yeah. But
Hey,
I don't care.
Jim, we all want a conversation here, right? We don't got to call
kill
names.
him with kindness.
It's
yeah,
not
okay.
recorded, by the way, just in case.
No, I'm not just going to sit here and kind of
what's the-
calmly
hang
talk
on,
and then
hang
get
on.
talked over the whole time.
Look, all I'm pointing out is that Soundly was calmly talking. You were calling him names. Now, do you mind if I show you something? What's it?
No, he wasn't answering the question, so would you like to answer it?
Oh, okay, can I show you something?
I'm not going to listen to y'all explain this point until you understand my rebuttal. My rebuttal.
Geometry. I think your answer or your question was something about geometry requiring something to be somewhere. Was that the question?
Yeah. To do something geometrically, does it require an actual location?
Well, all it requires is that you can see it, right?
That's an apparent location.
Well, where are the converging rays converging on? Is it apparent or real?
Apparent.
Oh, then I guess it doesn't matter if apparent doesn't mean anything.
Well, the sun is an apparent location. You cannot deduce an actual location from apparent using geometry. That's literally not debatable.
So what you're conceding is that it could be 93 million miles away. Is what you're saying.
Well, no, because it wouldn't always convert. I've already explained the argument like 5 times. No one's responding specifically.
No. What you've just conceded is that you'd have no idea where it is because it's an apparent location.
Well, I do agree with that. Yeah.
Open to interpretation now.
Sure.
It could be 93 million.
Well,
miles
no,
away.
that's you had to add the little cherry on top. No, but it can't be 93 million miles away. It necessitates parallel rays and convergent rays onto the singular light source.
But it's an
not
apparent
consistent with that.
location.
Yeah, it's an apparent location. I agree, my friend. But if it was 93 million, it isn't about the apparent location of the sun. It's about the rays.
Million miles away because it's only an apparent location.
It's not about the apparent location. It's about the rays.
So it's only an apparent location.
But it's about the rays.
Okay, if it's
I
about
brought
the
up the apparent location because you invoked geometry.
If it's about the rays, the
Holy
rays
shit.
are at the same angle. So they're
I brought up actual location because you invoked geometry.
Into the corner in two different directions.
You just falsely tout victory and you talk over me, and this is why I called you a clown.
So ping you into a corner.
Then how about you stop interrupting? Then you wouldn't have to interrupt. Hey, Soundly, if I'm in a corner and I'm a helpless little defenseless person right now, you wouldn't have to interrupt me every time I talk.
Because you're an arrogant asshole.
Oh, look, more of your feelings. Yeah. So anyway,
And you play the victim and say everybody else is talking over you.
okay, are you done yet?
Try and move it on.
Okay, so I only brought up actual and apparent location because you invoked geometry. In order to make a geometrical deduction, you must have an actual location. That's not debatable nor negotiable. So I'm not going to argue about it. So I only brought that up because that was actually a diversion away to you saying that taking measurements of angles will be similar in the same perception as what's of the sun in the sky, the apparent location. So that shows you that it's 93 million miles away, and that literally doesn't at all. For one, like it could be all kinds of distances and not change. Secondly, I don't make a claim to the altitude because it's just an apparent location. But my bigger point, which is not that at all, is that the rays themselves behave as if they were divergent. They're not consistent with what would be necessitated by parallel rays. So that's my argument.
Except that Stanley's already shown you.
Yeah.
Except that Stanley's already shown you that those rays can be nearly parallel.
Yeah, exactly. They're measured.
No, they're not parallel if they're converging onto the sun.
Can I make a point? 2 points, please.
Are lights that converge on the sun parallel?
Are you going to let somebody else talk for a second?
Well, none of y'all are answering the question, so I'm gonna go.
Everyone's having a go, and no one's like really replying. It's just a lot of you's going in one after
a number of different times, and he keeps talking over me. That's not true.
That's not true, Soundly. You interrupted me 10 times.
Can I please make a point?
Yeah.
Everybody, can I get y'all to calm down a second?
If you would like to go ahead, yeah.
I appreciate your allowing me to go ahead. I'm screen sharing. Do you see my screen?
No.
Okay. Can you click on my name and hit view?
Oh my god.
Right, don't worry. I know it's frustrating with it, but fucking hell, it's like just chill.
Okay, you have a green screen. What's up?
Great. So before I just put on display, depict what Stanley is talking about, I want to remind you that parallel lines converge in the distance, right?
Okay, I'm not watching this because you're going to skip past what I've already said. So
Okay.
Thank you for at least letting me know you were about to do that instead of wasting my fucking time.
No, look, everybody has sat here and listened to you. Okay, what I'm asking
you're about to literally conflate actual and apparent location right after I've already said it. And you're going to act like you're fucking teaching me shit. And you're going to talk down to me with a little passive-aggressive tone, and I'm not going to listen to it.
Relax, all right? Let me show you something. All you see is a green screen, all right? You don't know what I'm going to show you.
You just brought up what Soundly said.
I did, because it's true. Parallel lines converge in the distance.
Are you about to show me an apparent location and conflate that to actual location?
How about you let me show you and
well, then fucking get to it, man. Stop with your little color commentary.
Stop moaning then, Witsit, and saying you're not going to watch it.
But he won't hurry up. He's done nothing. He's trying to
need
recap.
To hurry up. We just all need to calm down. Just
no. Negator talks to me like I'm his little bitch. And it's not going to happen. So if he wants to hurry up and respond, that'd be cool.
The argument's already established. I know what he's going to try and demonstrate.
You don't have to
stay out of it. I don't like the way that
what he's going to say. So prove
I don't
me wrong
like the way that you speak, Wipsit. But
that's cool. That's cool. I've talked to Negator numerous times. He runs around talking shit behind my back, so I don't have respect for him. I'm not going to pretend I do.
Stop ranting try and sound like a normal person.
Okay, hurry up,
Go
please.
ahead. Go ahead, Negator.
Thanks. So what I got here on my little green screen, I got 2 points, right? They can be you in Tennessee and someone else 50 miles away. All right. It's dawn. The sun is coming up. Both of you whip out your compasses. You draw an azimuth to the sun. So here's you drawing your azimuth to the sun. Let's say for the sake of conversation to make it easy, this is let me hang on. We'll do 90 degrees. It's rising 90 degrees east. This other observer whips out his compass. He measures 90 degrees east. Right? Do you see kind of where I'm going with this?
I've already responded.
Let's say the sun were rising 100 degrees east.
The sun apparent location.
Yeah. The angle right here between you guys, if this line right here, if I extended these lines like so, all right, this is an angle between these lines is what? Is it 90 degrees at both corners?
This is an apparent angle since it's only an apparent location.
No, I've already said that. That's why I'm not going to sit here and play your game. So, and what's funny is I called this before it happened, and I was everyone acted like I was just being a bitch or something.
What's wrong with this demonstration?
You skipped right over what was my original point prior to your little demonstration.
Are the lines parallel or aren't they?
What was my original point prior to your demonstration?
I don't know.
Okay, I said it before you did it too. So yeah, you're deducing an apparent deduction. That's a cool story.
But you're claiming these lines are converge on a point, but they don't. They're measurably parallel.
You're measuring them back to the apparent location of the sun. So if the sun doesn't move the way you're presupposing it would if it was closer, then your entire point is moot. And again, you're deducing on an apparent location. What? So can we move on now?
No.
At what point do we go?
Okay, well then I'm going to leave.
Well,
hang on.
Are the crepuscular rays apparently parallel or apparently converging or literally parallel or literally converging?
I see that convergent rays, or more so divergent, it appears divergent rays with crepuscular rays converging on the singular light source. That's what I see. Now, I do know that the sun's just an apparent location, but that if the light rays are parallel, it would be all over the sky. I'm not going to listen to you continue to monologue about a presupposed interpretation. There you go. You have to interrupt me because you're a little clown too.
Well, because all you're doing is saying you're not.
No, I just watched him draw on a like a 5-year-old, and now I can respond. So
you did respond. You did respond.
How am I getting destroyed? I destroyed this before he did it.
You did respond, and then you finish your response by saying, "I'm not going to listen to any more of your response," which is
because
really
he's not responding. If you're being honest, he's not honestly.
Why should anyone listen to what you have to say if you're not prepared to listen to what they have to say?
Because the way the intellectual exchange works is you're honest. And I've already answered this. Now, if he skips over my rebuttal, presupposing apparent location to be actual, once again, then presents it as evidence, and then I have to recycle what I've already said. And then when I do, you people act like there's no relevance to it, and he gets to successfully skip over it, getting amped up by a crowd of people. That's a fucking joke.
You're simply lying to say people are sidestepping your rebuttal. They're not.
Yeah, this is an apparent location. Is this an apparent or actual location?
All I'm measuring is light rays, which is what
to
you
where?
were discussing.
To where?
It doesn't matter where it goes.
It doesn't matter where you're measuring it to? How do you get an angle?
We're talking about light rays, aren't we?
How do you get an angle if you don't measure it to?
Are we talking about light rays, or aren't we?
We're talking about you're conflating light rays with the sun.
Okay, well, tell you what. I can turn around.
Can't respond. Shocker.
I can turn around with my compass, and I can measure the angle that my shadow makes. Now, my shadow doesn't go to the sun, now does it?
So you're going to just skip right past all of it.
There's nothing to skip. You're making a specific claim about what those light rays are doing.
Yeah, but you're conflating. You're conflating light rays with the sun itself.
So light rays don't come from the sun?
They come from the sun, but you're trying to look at the apparent location of the sun and tell me about the light rays when I'm talking about just the light rays.
Well, I'm talking about just the light rays because it's the light rays that make the shadow, right?
Yeah, sure.
Okay.
Well, really, no, it's the physical obstruction. But whatever.
Right, but in order to have a shadow,
you have to have physical obstruction.
Physical obstruction, you must first have a light ray.
Okay.
And what I'm telling you is that we're both talking about light rays. And I think we now agree upon that, right?
No, because your little demonstration was drawing lines to the sun.
Well, no, I'm drawing light rays.
No, you were talking about tracking them back to the sun.
Okay, then in my demonstration, both of my observers turn around and measure an azimuth to their direction that their shadow takes.
Okay.
And that direction your shadow takes is still parallel from both observers.
Both observers where?
In my demonstration I gave you.
And they're how far away?
They're however far away you want.
Oh, so no matter where on Earth, we're going to have exactly the same shadows.
No, but in my example, I told you it was at sunrise, and I gave you 50 miles. Do you want it to be 100 miles?
Well, no, I'm saying that's 50 miles. That's not very much at all. The sun is it's pretty far away. So what is your point? It's not 93 million miles away.
Well, what sort of distance?
It's not 93 million miles away, dude. And the fact that you people think you know that for a fact is so funny. It's changed 6 times in a century.
I haven't made a claim about the distance to the sun using this methodology.
Okay, yeah, fair enough. Someone else always has to jump in. But
okay, so
what's it? You understand that because of the inverse square law, if it was 3,000 miles or 5,000 miles away, we would see a big difference, for example, in the solar flux over the course of the day.
That's an assumption. That's assumption. Assuming the medium.
Let Negator finish his point.
Let's get a long way away from the point. The bottom line here is that we now agree that if I'm measuring the azimuth to my shadow, or I could be standing next to a telephone pole and run my compass along the length of the shadow, those telephone pole shadows will be parallel, right? Now, like I said, you need 2 people that are both observing sunrise, which infers they can be only specific places on Earth because one person can be at a place where he's not observing sunrise, whereas another can.
So the rays are coming from the same relative direction.
You keep going back to this, but remember, we're measuring
Going
shadows.
back to what? It's the first time I've said that.
The problem here is the shadows are parallel, right?
Yeah, the light is coming from the same relative direction for the second time.
So what's the point or the problem? We're showing you that the rays themselves are parallel.
No, just because you're viewing a sunrise. The sunrise is right there. It's coming at a certain angle.
What's your overarching point here?
What's your overarching point here? You're making a claim that isn't true.
That's exactly the point I was making earlier that you've been disagreeing with the entire time.
Yeah, that's all you ever do is jump in and say shit like that. So anyway,
the point I made, I said on the left side of the screen, the person's going to measure the angle. The right side of the screen, the person's going to measure the angle.
To what? The angle to what?
Those rays appear to be diverging in your mind, right? But you can actively measure them. And
no, that's not true. He just now set aside where both people are seeing the sunrise, so it's a certain relative direction. You're assuming what the sun would do based on if it wasn't really far away. That's a cool story, but that's nothing to do with reality. So if you would like to get... Hey, what his point was, you just jumped in and said that I dismissed your point. No, I very specifically addressed it. You were measuring angles. You were measuring angles to what?
I told you exactly what we're measuring.
Oh, so now, so are y'all willing to disavow the sun then? The angles to the sun. Wait, stake the claim or disavow it.
What's it?
They're the same thing.
They're the same thing. A shadow is the same thing as the apparent location of the sun.
Right, angle to the sun, yes, absolutely.
Yes.
Okay,
Shadow is
so
180 degrees opposite of where the light source.
so if the sun's in the same relative direction to where we're getting our shadows, are we expected to see them differently?
What are you?
That's the point.
Yeah,
No, but you're assuming it would be drastic and detectable over something like 50 miles. That's your assumption. So good try.
You're showing
Yeah,
a picture
yeah,
that has
oh, yeah,
a drastic
oh, yeah.
divergence, and you're claiming that that's the actual angles to the sun.
I'm saying
And
they
it's
are
not.
always
Those are
strictly
actually
converge
parallel.
onto the light source. But if your fairy tale is true, they do it all over the sky, and no one's responded specifically to it yet. Scott did the best here. Scott did the best here. I'll give him that, but he still didn't even address it.
What does all over the sky mean?
I've already explained it.
You've
What
said
else
it
would that
several
mean?
times. I have no idea. Can you draw
Oh,
me a
okay.
picture?
You don't know what all over the sky means. That's pretty interesting. So the light comes in at parallel rays from the sun all over the sky. And so if there were crepuscular rays caused by physical obstruction diverting the light rays, or at least just perceivably, that would happen any and everywhere. It wouldn't strictly happen to converge on the singular light source.
The rays would not converge on the light source?
Yeah, in your model, there would be crepuscular rays happening all over the sky randomly because of clouds. They wouldn't always just go back to the central light source of the sun.
Why?
Because they come in at 90 parallel or 90 degrees all over the sky. So if they're parallel all over the sky, once it comes in entering parallel, it has no preference as to convergence. It would simply because the parallel ray, its convergence so its perceived convergence would only be relative to where it begins to be physically obstructed, which would be a cloud. That would happen all over the sky. It was perfectly straight till it was obstructed. But they only converge on the light source. They do not do that in reality.
So they don't converge on the light source?
No, that's all they do in reality.
Okay. Nobody's disputing that light rays come from light sources, and visibly those light rays converge in light source. I'm not sure.
But they're parallel. They're parallel. So yeah, you are. You're just not responding. I'll say it again. So if they all come in parallel, that means every light ray that enters Earth's atmosphere is coming from the sun, and it's parallel. That would be all over Earth's atmosphere. Every single portion of the sky that's lit up is being lit up by parallel rays coming straight in. Okay, so as they come in straight in, if they hit a cloud that obstructed it and diverted it, it caused crepuscular rays because it was straight, and then it caused the perception of it being diverted. But it was straight right before.
Clouds don't divert rays. I don't know why you're saying this.
Well, they cast shadows in the rays.
But they don't make the ray change.
Yeah, good thing I said perceivable diversion, I suppose, huh?
Nope.
I didn't say that?
I'm not. I'm just trying to figure out what you're telling me.
Yeah, okay, obviously. So, anyway, perceivable diversion is what I said like 3 times, but it comes in straight prior to that perceivable diversion. That would be caused by something like cloud. That would have no specific preference as to location in the sky, because all the light rays that then turn into crepuscular rays would originally be parallel with no preference of central point.
No preference.
That's your model. That's your model.
Nobody's
Can you explain that? Like, how is light coming from any other source but the sun as the sun's moving across the sky? You're acting like light's appearing somewhere else, and you're also acting like the whole of Earth is lit up at once.
No,
So, I mean,
not doing any of that.
Can you, like I said, I mean, you may see. Here's the problem: you may run 100 miles an hour with your words, thinking you're on the point because most of what you're trying to say is already in your understanding. But maybe kind of go into the explanations a little bit deeper to kind of premise your argument.
I'm
So,
trying
for example,
to, man. They're coming in parallel, my friend.
So when you said all over the place, you lost me as well.
Okay, half the Earth, the part of the Earth that's lit up, obviously, right? And then the light rays are traveling from 93 million miles away, and that's why they're parallel on Earth, right? Because the radius of the sunlight is so huge relative to the Earth that we get hit with just a little portion of the radius of the light, right? And so they come in parallel, basically perfectly parallel.
Right.
So then they come in and we're just getting a little bitty fraction of that light, and all of it's parallel. And so that means the whole side of the Earth that's lit up, that whole entire portion of Earth's atmosphere is getting hit with parallel rays.
Right.
They're all just parallel. They don't care at all about what we perceive from the Earth, anything like that. They came in parallel. And once they get into the Earth's atmosphere, if there was some physical obstruction that causes the illusion of divergence, that would happen all over the sky because they're parallel all over the sky. They're not just parallel in the center. They're parallel all over
Yeah.
the sky in the model, and so they would happen. Crepuscular
but
rays
the
would happen
model-
all over the sky.
Yeah. But let me just make a point. You're making the suggestion that the sun hits the Earth, but what you've got to understand is, in our model, if you take it for what it is, the globe is turning away from the sun all the time, and another part of the Earth is rotating towards it. So the sun is moving based on the way of the rotation of Earth, and so the sun's always striking the Earth at some point.
Well,
so the idea that it's kind of moving and shining the Earth it's completely wrong.
What I don't understand, what
we're
Winston is
turning
saying-
into the constant light.
That's not
Winston is trying to have it both ways. He says you cannot locate the sun because when we ask him about, well, how is it that everyone sees the sunrise in the east on the equinox, or how is it that the ground speed of the sun doesn't match up with the flat Earth? He says, well, you can't locate the sun because you don't know what the sun is. But then now you're saying that you can locate the sun because of crepuscular rays. So which
No,
one is it?
I didn't say
is
that.
It that we can? Is it that we can locate the sun in the sky because of crepuscular rays?
We can
Or
always-
we can't because of the sun rising due east for everyone on the equinox.
We can always locate the sun as its apparent location. We can always do that if it's in the sky. So what are you talking about? Y'all are measuring
Well,
ground
you're
speed,
saying-
and then assuming that on a flat Earth the sun would have to travel faster for it to maintain and not fluctuate. And I said no, maybe it does move slower or faster, but our perception doesn't change. It just keeps the same ground speed. Now I'm just saying that you
So
don't
then we
actually know.
can't
You're just
locate
making
the sun.
assumptions.
So we can't locate the sun.
You can locate only the apparent location. But if all the light rays converge onto that singular location.
So we can track the speed of the apparent location then, right?
You can look at
We
the
can
ground
track the ground
speed and
speed
see.
of the apparent location of the sun, right?
Well, you can compare the two, sure.
But we can definitely track the ground speed of the apparent location of the sun.
We can
right?
see how much of the Earth is lit up for how long. Yeah, of course.
And then we can do the math on that. And for some reason, it's the same for both of the solstices, whether it's over the Tropic of Cancer or the Tropic of Capricorn. It just happens to be the same for no good reason on the flat Earth.
Well,
but
the
for a
good
very
reason is
on the
just that
territory.
the good reason is that the Earth is a very harmonic system, and the sun moves over top of it, and there's always the same amount of Earth lit up at the same time.
And then at the same time, we can't. And for the same time, we can't explain on the flat Earth why the sun rises in the south for observers in the southern hemisphere. There's no good reason for it on the flat Earth, but there's a very good reason for it on the
No,
sphere,
the sun moves over top of us and can be seen relative to location.
No, but the sun rises south of east and sets south of west for observers in the southern hemisphere.
Yeah, relative
which
to
is
their
not
southern
possible.
position.
That's not possible on any flat
That's
Earth.
just a claim that you people say.
What do you mean it's a claim?
Yeah, it's relative to their southern location. That's what their perception is. So.
Thank
You're saying that people in the southern hemisphere
I
don't
know,
know
exactly.
where south is?
I'm saying that what they see is all relative to their location.
No, they can use the sun as a relative point because the sun is always to the north of them during the middle of the day. For observers in the southern parts of Australia and Africa, the
Why
sun
do
is
you keep
always north
conflating
of
so
them.
much shit?
No, because
You're making different claims now.
You're claiming with the crepuscular rays that we can pinpoint the location of the sun because
No,
the
I
rays will
didn't
trace
say
back
that.
to where the sun is.
Well, fair
the
enough.
apparent
Kind
location.
of, sort of.
The
Yeah,
crepuscular rays pinpoint. They pinpoint the local sun, right? They trace
Well,
back to the local
they
sun.
behave as if they were divergent rays, and they track back to the apparent location. Yeah.
Okay, the apparent location. The only problem is the apparent location is in a different direction for observers on the Earth, on the flat Earth.
Because they see it differently from where they are. You can replicate this through practical demonstration.
Well, they all see it on the east. Everyone on Earth sees it rise due east on the day of the equinox, which means that the sun is apparently in a different locations for all the people on the Earth.
That's
on the flat
not
Earth.
true.
Also means
That's not true. Once again, all you have is the apparent location.
How could the sun rise due east
I've
for
already
all
answered it.
observers on the
I've
flat
already-
Earth? How?
I've already answered this. So
What's the answer?
It's there's an apparent location of the sun relative to the location of the observer, and there's a circuit overhead.
I'll grant you it's the apparent location. Why is the apparent location in the same direction for all observers on the flat Earth?
What are you saying? It should be different?
Yes.
That's a claim. That's a claim. You're claiming it should be different. You would need to know what the character.
Lord.
You don't like this answer, but this is the answer. I'm going to say the answer. I know no one here likes it, but this is the answer. You would have to know the characteristics of the sun and the medium it's encompassed in to fully understand our perception and how much is expected to fluctuate or to explain the lack of.
So the answer is I don't know.
The Earth is pretty magical, yeah, dude. Yeah, it's like perfect. I don't know if you've caught up with that yet.
There's also this weird problem that the moon is always illuminated in the exact pattern as a ball that you're holding up. If you can illuminate a ball with the sun, if the sun and the moon are out in such a way that you can see the moon and hold up a ball and also illuminate the ball, the shadow pattern will match the ball that you see on the moon, which is showing that the light rays are exactly the same as what's hitting the moon.
How do you know the moon is a ball?
Oh, it appears like a ball because
no, it doesn't. We only see one half of it.
We see more than half of it.
You can look at it. You can see the contour lighting on the Terminator, and the way that the shadows are illuminated. You can see that it appears like a curve.
That's why moonlight is colder because it's reflecting sunlight.
But that's still, hold on a second. You're still ignoring the fact, though, that if you do this experiment where you hold up a ball whenever you're looking at the moon, it will illuminate the ball exactly like the moon. Why does it do that on the flat Earth?
Why? You're asking me why the moon does something and your model can't even explain it.
The model perfectly explains it.
No, this is what your model says. Okay, I'm glad you brought that up. I'm glad you said that. So this is what your model claims, that the sun and the moon are just coincidentally optically the same size, but they're actually not at all, right? The sun is 400 times bigger, just coincidentally exactly 400 times further away. At the same time, they say that the moon is tidally locked based on gravity, which is it's very selective, though, of course, right? It doesn't mess with puddles or anything. And then time out. It's locked. It's coincidentally locked at such a perfect speed.
Monologuing with
yeah, there you go. You're scared to hear it. It's coincidentally locked. This is the actual model. It's coincidentally locked at such a perfect. You have to keep interrupting me.
Please don't all just talk over him. Witsit, try and wrap it up. It's going on.
It's just actually not really. It takes about 10 seconds to say what I'm saying. So, yeah, they say the sun and the moon are just apparently the same size, huge coincidence. At the same time, the sun or the moon just moves at the perfect rotational speed, if you will, so that we only see half of it.
So Witsit.
So that's what y'all believe. Y'all believe that for all recordable history, you see one half of the moon coincidentally.
You know that we see more than half, right? You know that lunar libration is a thing. That's another way we know it's a sphere because of lunar libration. We see like 58% of it or something.
No, we don't.
Yes, we do.
No, we don't.
There's time-lapse video that shows it.
Yeah, please provide where you know that it went around this other side of a ball. That'd be great.
I'll get you a GIF, man. You just save it. It's a libration GIF. And I just want to say, I'm not going to speak over too long. I just want to say real quick that the moon, the fact that it always appears like a circle, is actually the direct evidence that it is a sphere.
That's a cool story.
Well, sphere is the only geometric shape that can possibly do that for any angle.
Well, actually, that's assuming, assuming solidity, which I will concede the moon does appear to have some texture. I'm not gonna lie about that, but you have to assume an object or solidity, and then again, we don't understand the perception because of the medium it's encompassed in relative to where we are on Earth. I know you don't like those answers, but that is just the truth. So that's why I stay where I stay.
That's all it is.
How is it is nonsense? I'm not going to jump out and just stake my entire worldview or cosmological interpretation upon authoritative figures that tell me there's a perfect vacuum out here. That's not what I do. What authoritative figures do I stake my entire worldview upon?
Flat Earth YouTube video.
Flat Earth YouTube video. I disagree with QE on all kinds of things. I disagree with Nathan Oakley on all kinds of things. I disagree with Bob and Jeranism on all kinds of things. So you people just self-project that you think like a monolith.
That's where your views started from. You started from those views, and then you just made up your own bullshit.
No, that's not what happened. Actually, I found about Flat Earth 5 years ago. I didn't even hear about Jeranism or Globebusters or Nathan Oakley till the last 6 months. So y'all can try again. Try again.
Their shit. They also.
I don't even watch Nathan Oakley, so how do I repeat his shit?
And local sun. You repeated their shit like a good little repeating.
Well, actually, that's what you think, but everything that I come in here and say, I've thought about myself and come to my own conclusions. I don't even watch Nathan Oakley. I don't watch like really any Flat Earth YouTube videos because I'm working all the time. So
Doesn't have to watch
I don't
Nathan
care if you
Oakley
think
to
I'm
like
lying,
Nathan
dude.
Oakley.
What makes you? What? Wait, I want to know, dude. What part of your life what happened in your life where in which you determined that your opinion of me from a bullshit exterior position subjectively actually holds some weight? Because it does not. You do not know my motivation. You're incapable of
it does.
psychoanalysis of me. No one
Just
cares
to
what you
me.
think. You think I have to repeat other people. Now, some of the
not
arguments
for-
are the same. You know why the arguments are the same? It's because we have the same position. The Earth's a geocentric stationary plane. We're trying to find physical empirical evidence contrary to that based on the globular model that y'all
How's
claim
it
is real.
wrong?
So we say
But there
similar
is none.
things.
Why
There is no physical
psychoanalysis. We're saying you're parroting YouTube videos, which say
Yeah, but
exactly
that isn't
the same
true.
shit you're saying.
That isn't
You're
true,
saying
though.
exactly the same shit they're saying.
Well, just explain this to you. I know you may maybe pull your crayons out or something. If we have the same position that the Earth's a geocentric stationary plane, of course we're going to have similar arguments we've come to. If you think that I can't think for myself, I had to go watch a video and take notes and regurgitate it, you're clearly self-projecting your own behavior because I do nothing of the
Say
sort. So we
something
can move on now.
original, because all you've said was in these videos.
All right.
Name one thing you disagree on with Kiwi.
I don't think. Well, we haven't like really specifically clarified that we disagree, but I'm not like the biggest fan of quantum mechanics. Like, I think it's experimentally valuable, but I think the interpretation process is completely tainted by assuming physicality from the jump. I don't think about what other people think, man. Like, I think that's so weird, dude, that people do that.
I got a question for you.
Yeah, I think it's weird that you think about things without physical evidence of the thing that you're thinking about.
What? No, they
critical
told me I live in a certain model, and that's a physical claim about reality. So I wanted to know if that's actually the nature of where I live. So I went to go find physical evidence for it doesn't exist.
Right. Okay. So we talked about the top, right? We talked about you talk about how space being a privation and all the rest of it. So you don't believe in that, I guess.
Who did I steal that from? Just out of curiosity.
Unless you do.
Who did I steal that space is a privation from? Who did I steal that from?
Well, that's probably the most original thing I've heard you say, to be honest.
Okay. Yeah. So
I'll
I
give
don't
you that
steal
one.
things.
I'll
Okay,
give you
anyway,
that
go
one.
ahead. Go ahead.
And
Yeah, I
like,
think space,
you know,
space is a
there's
conceptual
only about
privation.
10 things you can talk about, so you might repeat other people.
Of course, it's
You
the
know,
same
when it
argument.
comes
Y'all
to the
repeat each other
flat
too, right? I mean, y'all have the same arguments too. So
Right. I think the globe arguments come from consensus tested science. But anyway, my question
what you
is, we talked about the flat top Earth, geostationary plane that you said. Now, have you ever thought critically about the foundation, what it rests on? And my question would be this: is it a column of water that the Earth sits on that just goes forever, if space is not real, or is it a column of Earth that just goes for like forever and ever and ever?
I'm not claiming if terra firma is finite or infinite or anything like that. And foundation wise, we can't.
I get what you're saying, but just logically, like there's
Logically,
the
I
idea
would
of having
assume
a
there was-
final foundation.
Logically, I would. This is speculative, but I would assume yes that it would be finite and have some type of containment. And I would also just kind of speculatively assume it's bigger than what we think we can model right now. And then as to the foundation, we haven't even gone further than 8 miles. So I limit my claims to that. I don't guess what's down there. That's what the globe Earth does.
Right. So just to sum up, a finite construction inside some type of container, and outside of that is unknown.
Sure, I think it's what we see in the sky. Yeah.
Okay. Cool.
Yep.
Thank you.
Yeah. Yep. I mean,
Witsit,
my position is forced to remain pretty open. If we're being honest, what's up?
Witsit, you got them on this triangle thing. They can't draw the triangles anymore. They have no.
Jesus Christ.
Tell
Jeremy,
them
we're
how
not
you don't
trying
need a
to draw a
location.
damn triangle.
You don't need a location. What is that? Just imagine it in your head.
Oh,
Use
you
your
don't
head
need an
location.
actual. You don't need an actual location to
I can calculate
geometrically deduce
I can-
something.
I can calculate what the distance of a hypotenuse is, of a right triangle that is sides 2 and 5 in my head without using a location.
So an apparent distance.
I can calculate the hypotenuse of a triangle with sides 2 and 5 in my head abstractly without using a location. They can
Okay,
do
is
abstract geometry.
where they converge have to be a physical location to accurately deduce
No.
a distance? Well, then you're a clown. Okay,
That's
well,
not true.
True. That's not true.
It is true. Pythagoras' theorem tells us that a squared plus b squared equals c squared. So I have that formula. If you tell me that two of the sides are 2 and 5, all I have to do is go 4 plus 25 equals 29. Square root of 29 is the length of c. Now I have the answer, and I didn't need a location to do it.
Yeah, actually, you did. The way you get your angle, the way you get your angle is you converge it onto an apparent location.
Well, if it counts inside my head, if a location is inside my head, then what's not a location? If I can do it abstractly in my head, then
then you're just doing some abstraction,
including inside your head.
Yeah, you're doing some abstract bullshit in your head. What's the bullshit in your head represent in physical reality?
Well, it works.
Count on his fingers.
Wait, it works with what?
Do it in his head.
It works with what in physical reality?
I just got a distances correct.
Okay, but you need to know the point of convergence to get the angles.
Scott,
I can tell you the angles too.
Yeah, but you can't whenever we're talking about the real world and you're telling me how far the sun is and stuff. So we can move along now.
It's just not true what you're saying. I just did it for you.
Inverse square law relative to perception, attenuation of light. There's no way you can deduce the actual location to make a physical claim of geometry. You need an actual.
And by the way, you're just listing.
You always say it's word salad, and that just shows your lack of intelligence.
And just shows your stupidity and ability to make word salads.
If you say that it's word salad when it's exactly specific, that's showing that you just don't understand.
What I want to know, though, I have a question. Is it possible, then, for us to ever know the distance to the sun?
Without actually traveling there, no.
So the only way we could do it is to travel there.
Yes.
But we have before traveling there, we have no way of knowing how long our journey will be.
It inherently has to be an approximation because all you have to go off is the apparent location, which we know for a fact. We know for a fact that it's a perception. So
we can make an approximation.
Sure, but it could be
it
could be 500% off though.
500% off. So we could set off on our journey with enough fuel. And then find that actually we've only got a fifth of what we need. Is that what you're saying?
Sure. What I'm saying is if you deduce the distance based simply and purely strictly upon the apparent location, then yes, you are automatically putting an asterisk on your deduction.
So I don't understand. How could we possibly travel to a place if we have absolutely no idea how far away it is?
That's a great question, Jim.
Well, I would say the answer is we couldn't.
Yeah, I would have to agree with you.
Okay, so you would have to conclude then that there is never going to be a way that we can find out the distance to the sun.
But you're implying
without going
no way to travel to the sun.
And we just agreed that there isn't a way to go there
because of optical geometry. Parallel lines are going to converge with your angle. Aligns. So your angles are going to be off.
We've just agreed with it that we wouldn't be able to go there.
Yeah. Okay. So, in your paradigm, certainly probably not, right? It's 93 million miles away. I'm not going to make it.
In your paradigm, where there's no way of knowing it with even a 20% certainty
right.
of the distance.
Right. Yeah, I will concede. Yes.
In my paradigm, I know specifically how far away it is.
Yeah.
And we've already sent many spacecraft there.
You sent spacecraft to the sun. Yeah. Okay.
Yes, right.
Okay.
Many spacecraft have orbited the sun.
Okay. Yeah, I will concede if you were to try to go and actually empirically validate the distance to the sun by traveling there, but you didn't have an accurate foundation, you would probably have some issues with navigation, if you will, right? You would have some issues getting there, but it's not necessarily impossible that you would find it, right? Because you could always just update relative to what you perceive. But yeah, I would assume that you'd have to calculate for way more fuel, etc. But so anyway, yeah, I mean, my point is I don't claim the actual location of the sun. In fact, I very adamantly claim the opposite.
That's really my point. I think that most of the time you seem to be doing this. You bleat on and on about physicality, and yet every time anybody tries to refer to physicality, you always throw in that there's some reason why we can't know about this particular piece of physicality.
Because we can't experiment with it.
Well, then you argue yourself into a position of assured
Well, I
ignorance.
admit via intellectual honesty where I do not know.
Not only do I not know this, there's really not really any way I can ever
It's
know
called
this.
being
or anyone
honest.
else. Well, if you think so.
No, what do you
I
mean
call
about that? That is my honest position. Would you not agree?
Well, I call it willful ignorance.
Well, that's what you say because you are on a
coming up with-
convenient side, right? Because you have an answer crafted for you already.
No, you're just coming up with imaginative ways to say
That's
I don't
what they
believe.
did.
But you're just coming up with imaginative ways to say I don't believe you.
No,
And
no.
that-
What I'm saying is that
Not really.
if you examine the core claims of these things, like the way they did it was not
Right.
sufficient.
Right,
Yeah,
we can't
that's all I'm
know
saying.
anything. Great.
Well, you can't know things like definitive distances to celestial bodies. No, we can know things like terra firma, and there's no
I'm
actual
sure there's
rotation.
I'm sure there's other. Well, no. I mean, the current ways that we use to measure terra firma, you reject those as well.
Well, because it's
we
applied
don't know
to-
where the moon
it's
is.
applied to
We don't know what
spherical
the
assumption.
moon is. We don't know where the sun is. We don't know what the sun is. We have no way of knowing how big the oceans are. We don't know anything.
Well, if we could
You-
freely
trigonometry
travel, maybe we could
doesn't
figure
work.
out the oceans, but we're not allowed to do that. So
I wonder why you're in an argument.
the fact that people in here still think you can freely travel is just ridiculous.
I wonder why you're in an argument expounding your ignorance. That's
Wow.
all you have to offer.
Well,
is to say,
because
"Oh,
this is-
I don't know.
that's what I'm
There's
trying to
no
say.
way for me to know.
I'm
You
glad
should
you
be
brought this
like
up.
me and not know stuff like me.
Yeah, I'm glad you brought
I
this
think
up. This
that's
is a great.
idiotic.
Fair enough. I'm glad you brought this up as a great point, right? That's like the main hiccup for Globers is because to even really challenge this. See, look at this, dude. To even really challenge it, you have to let go of whatever explanations were crafted for you that you currently believe, and through that process of examining those, once you reluctantly have to falsify them, you don't immediately have a replacement. Some people would rather not even look into it or hold on to the current explanation than even the mere possibility of being in the position that you just outlined, which is the intellectually honest position of not knowing everything. So, I mean, that sounds like a personal problem.
But it's not that you don't offer a current. You aren't currently offering a replacement. Your arguments lead you to a place where there could never be a replacement.
Well, maybe we're not supposed to understand everything in the sky, dude. Maybe they took your attention
you're
away
happy-
from the Earth. That's funny to you. It's funny to you. Yeah, but whatever.
Oh yes, because what you're saying is I'm happy with ignorance. I just want to be ignorant.
Well, no, I'm happy. I'm happy
not
about
happy
not.
with ignorance.
I'm happy about not knowing something prior to just believing something I can easily falsify. So,
What
yeah.
have you done to actually determine the answer?
Falsified the one they gave us, so I know. All I've done is remove that.
Falsifying an answer, give you an answer.
No, I'm trying to explain it. Falsification is independent of replacement.
Okay, but if you can falsify that the Earth is not a cube, does
Yeah,
that
but that's
by
not what that's not what I was
definition mean
told
that
when
it
I was
is
5 years old. Yeah, that's not what I was told when I was 5, though. So
Stop.
well, stop
If
bringing
you
up stupid shit like
falsify
a cube.
That the Earth is not a cube. If you falsify the idea that the Earth is a cube, does that mean that it is a pear?
Did you feel dumb saying that?
John.
No, not a bit.
Okay, well,
I think that's a very good question. If you falsify the idea that the Earth is a cube, does that mean by definition it is some other shape that you can define? A pear shape, for example.
No, because falsification is independent of replacement. Are you not listening?
Falsification would be adequate in a true dichotomy. If you falsify one and it has to be one or the other, then it's the other by default.
Have you determined or proven that it must be one or the other?
Yes.
Well, if the surface of the Earth
internally
isn't
organized.
curving, then what is it?
Have you proven that it's not curving?
Well,
Could it
this
be
is a
pear-shaped?
hypothetical. It's a hypothetical
Could it be
preface. It's a
could it be
hypothetical
pyramid?
preface. It's a hypothetical
Could it be a
preface of
pyramid?
if. Oh my God!
Would,
It's a hypothetical
would the Earth's
preface of
surface
if.
curve if it was a pyramid? Would the,
Yeah,
would the surface of the Earth curve if it was
Hey,
a pyramid or a
can
cube?
I answer, or are you just going to keep saying stupid shit over and over? So the surface of the Earth being flat is not a shape. You understand that, right? Okay, cool.
Can
So
you-
if the surface of the Earth isn't curving anywhere, then what would be the surface of the Earth be?
It could be a cube.
A cube is not answering the question. I just told you the flat or curved surface isn't a shape claim.
Okay, well, a cube would have a flat surface, would it not?
Until it curved.
Where does a cube curve?
Oh my gosh, dude. Okay. Yeah, at the corners. No. Dude, I asked you a question. If the surface of the Earth isn't curving anywhere, then what is it?
Okay, it's what? Does that
okay, thank you. Now that you brought up a shape again. That is so stupid. Okay, so the surface of the Earth is nothing to do with it. You have to interrupt. This is bad, dude.
Yeah, please don't.
Shape claim.
Let him get a full answer out.
Finally,
shape claim is not the same as the surface, right? And it was a conditional preface because you basically challenged Lemon about basically saying it was a false dichotomy. I'm like, okay, well, if the surface isn't curved anywhere, what is it? That's flat. That isn't a false dichotomy, right? It's just a logical deduction. I just wanted to agree upon that. Now, you consistently divert away from that and conflate it to a shape claim. That is not what that is. They're different.
I'm conflating things. Yes. Really great words.
Could you just
what if I can actually measure?
Hold on. But just for once, just stop combating and just try to understand each other. I know he talks fast, but he's not wrong in a lot of things he's saying. You're just trying to look for something to
He's
twist.
pretty wrong.
He's trying to twist things and make him out to be more wrong than he is. Let's put it that way.
The thing is, we're making contradictory.
Well, like
we're saying
that
that
about the shape of the Earth. If it's not curving, what is it? Obviously, it's flat. And then the guy has to go and subscribe, and then ask some questions like, "Well, a cube where does a cube curve?" Obviously, at the fucking edge, don't it? It's dumb questions, and you're just intentionally not understanding him.
But
that's what I want to add.
They're making contradictory claims by saying that the Earth is systematically and regularly curved by this gravity-making mechanism, which would make it predictable with lasers and other things by 8 inches per mile squared relative to a straight standard. You can't claim that small to large-scale proof of this curvature. You can't make both claims. So either the Earth is internally curved with some sort of curving mechanism into a predictable ball shape, or barring that, it is probably externally pressed and or most likely flat. So that's the true.
So now that we're done with that, what if we can demonstrate that there is curvature of the Earth? You can measure it. Any of us can.
Just try to understand him rather than just trying to look for something to complain about. That'll be better because we can understand each other more then. But I don't see no curvature, Bob, so I don't know what you're on about.
Look at how Bromy implies that we did not understand what shit he was saying.
You were trying to twist what he was saying and just look for something wrong. All you do is look at problems.
Stop lying, Bromy.
No, Bob just tried to address the idea that there is no curvature that you can measure by saying there is curvature you can measure and tell him how to do that. Romy, stay on topic.
Whatever.
Rome is lost, so he can't.
Okay, so if there's measurable curvature and we all can measure it, how can you say the Earth is flat?
Oh, there isn't any measurable Earth curvature. That's just a fairy tale that you just say and it makes it true.
I measured it.
Oh, you measured the Earth curve.
Yeah, I personally
Holy shit, I'm excited, dude. Can you provide the evidence, please?
Oh my god.
Yeah, I thought today wasn't going to be fruitful, dude. This is awesome.
He videoed it.
Yeah. I can't wait, dude.
Yep.
I'm sure you've critically, already dissected it yourself, though. Sure.
Yes, as a matter of fact, I have. I've also talked about sources of error.
Oh, can you go ahead and let us know what those are before you present it?
We can actually physically measure the curvature, and so can you. How would you do it?
No,
how about you just stop just saying things? And I said I'm excited to hear it. So would you like to present it, or you tell us what it is, or something? You know how you would do it is you would be able to detect a consistent physical obstruction based on geometrical curve. But go ahead.
Yeah. Call the horizon.
The horizon's an apparent location.
It's called being able to.
You already lost.
You're talking about it, Bob. And show the room your evidence for curvature.
He already lost. He just invoked the horizon.
I'm going to go ahead and
talking about how you measured it.
Yeah, please show us. Just show us.
We'll just one of the 450 videos I've done.
Oh, just whichever one makes you the happiest.
They all make me happy. I think they're all great.
That's what's up, dude. We'll just pick whichever one makes you the happiest.
All right. What is your question about curvature? What would you like to know about
you said you have evidence, physical, empirical evidence of Earth curvature.
Yeah, I know. I've got 450
just
videos.
Present it, man.
You got a big dick. We know how big your dick is. Lovely. Show us the curvature.
Brahmi, come on.
Look at what you say. Look at him. Have a go at him.
Why? Because
he get away with it.
you have a
You know,
big
anybody
dick?
that throws your narrative to get away with it.
He asked which picture do you want to see, and you said, "Yeah, you have a big dick," and I'm supposed to yell at him.
Yeah, because he hasn't been
Oh,
sitting there talking about how he's made a curvature for the last
Because
5
he is
minutes.
showboating a little bit, Scott, I think.
Okay, the only
Thank you, Jim.
okay, the only problem that we have
Jim's
here
just
is we have
lying.
2 different mechanisms.
He is though. He said, "I've got 450 pictures. Oh, I can measure curvature. Oh, we can all do curvature. What curvature you want to know about?"
The only problem is we have 2 different
Get
mechanisms
curvature
for
out.
what form. We have 2 different mechanisms for what forms the horizon. Either it's a physical obstruction on a ball, or it is just an apparent optical location that could work on a flat plane. And so we need to differentiate between the 2. Is it a physical hump of Earth curvature, or is it, what was that?
It doesn't follow the rules that it would need to on a flat plane. For it to be on a flat plane, that any visible object that was visible, any object that was big enough to be seen, would be in front of a horizon on a flat Earth.
But
Oh my gosh.
It rises towards your eye level. That would only be consistent with a flat.
No, it doesn't.
It
Yeah,
rises
well,
towards-
actually, this is the truth, right? It's below you because you go up above the ground, but it does rise up some. It just it's still a little below you. So that's what actually happens. So try again. So is this dude presenting some evidence? I just want to see the Earth curvature. I've been looking for 5
There's
years,
a
so
image.
I mean, I'll come over.
There's
Maybe
a-
I'll come
there's
over
an
here
image
and
in the
join
debate
y'all
chat
server
box.
after this.
What?
There's an image in the debate chat box.
What about
you
it?
can see some curvature there.
That's not curvature.
Okay, well, I'm gonna let this other guy says he's
Okay, where
got
do you want
physical
me to put
empirical
this?
evidence of Earth curvature.
Winston, you reckon you could drag a few more people in here just for? I'll make sure that people here reciprocate the favour if you can round a few more up sometime. So it's not just you doing the battle, you know.
Yeah,
Jim,
we'll see.
I don't want to be disruptive, but I am trying to help. You know what I mean?
Bring a few mates.
We'll see.
Yeah,
If
well,
it
we,
works.
we want better quality than Brummy. You know what I mean?
Oh, come on.
At least Brewie's at least pretty awesome, honest when he doesn't know things. Someone say something.
Yeah,
The thing- that's the thing, I'm honest, right? When I don't know stuff, but you never get anyone on the other side.
Please.
You never get anyone on the other side concede anything or you know admit they got something wrong. They go quiet and they wait for someone else to jump in, and then they constantly switch positions, and then they all get away with shit, and I just see it all the time. You
Well,
guys need to like.
that's because we're correct, though.
Well, yeah,
So
but
you
that
say,
assumption
so
has
you say.
tainted the quality
That's
of
the big
exchange.
difference between us. Is we're
But that
correct.
assumption taints the
think you're correct.
quality
I used to
of
think that was
exchange.
correct when I was a global.
It's not an
Like,
assumption.
my friend, I even say that about flat Earth, right? Like the assumption of being accurate.
I know, but you're
if that's
incorrect.
if that's acted upon, that will taint the quality of exchange, and that definitely happens here. But it's whatever.
Okay,
It's expected.
Jim, I've got the link up, and it's at the time.
Absolutely.
So there's a photograph right there from J. Toll and Media One.
So that was your
clearly-
physical evidence you had?
Yeah, and
I
it
was-
clearly
I thought you said you did
demonstrates
this.
the predicted amount of curvature on a
I thought you said
globe
you
Earth.
did this.
So I've done others. Yeah, I personally did the circumference of the Earth. But you wanted evidence that shows curvature of the Earth, and here it is right here.
No, it's not. So does it look exactly the same
So
every day?
You're gonna hand wave off. hard-
No,
hard
I just
evidence
responded
in front of you.
to it. So how about you should put your listening ears on instead of just talking? Yeah. So is this the same every day?
Yeah.
Okay. Thanks for lying. Conversation over.
With the variance from day to day, doesn't the
Oh my
variance from day to
god.
day
Wait,
doesn't become
y'all.
enough
Wait,
to
time out. Is
match-
everyone in this room that much of a liar?
No, you
just
are.
get it
I want to know.
correct, dude. Get it
I
correct.
want to know. I want to know.
Get it correct.
Well, you see,
With the-
what this is
the variance
this is
of
a
the variance
narrative
in a
that they're
day.
presenting.
No, you
This is
just
a
said it
narrative
looks the
that
same
he's
every day.
presenting, and
That means
yeah,
you're
no,
lying.
You asked if it was the same every day, not if it looks the same every day. It is the same every day, whether or not you have some
All you
atmospheric
have
distortion
is
or
to
not.
see it, dude. So does it look the same every day?
Pretty much, yeah.
With it,
Pretty much, yeah.
with it, the variance that you see on a daily basis for that particular observation is never going to come close to what it would have to look like on a flat Earth.
Not even
The
remotely.
The problem is you guys have an imperfect understanding of how things would work on a flat plane. You're forgetting about angular resolution of the top and bottom.
You don't know
visual
what
zones.
angular resolution is.
Yeah, well, no, my meme just took.
Essentially,
yeah,
those
Lemon said it.
converge to a horizon line, and that's what you're not
And
getting.
I presented a meme. I presented a meme that demonstrates it. I presented a meme that demonstrates it. So some guy came in here and claimed he's done 400. He has 450 videos. He has physical empirical evidence of Earth curvature. He then invoked something else in the chat of a picture of someone else, or was that you that was talking? I wasn't paying attention, to be honest. So anyway, if it does, and then I said, does it fluctuate daily? And then you said, or is it the same daily? And you said yes. And then you said that I wasn't asking, does it look the same daily? So now I'm asking, does it look the same daily? And you're saying it doesn't fluctuate enough to where it would if it were flat. And I just showed a meme, a practical demonstration of how something can appear to go down and away from you, even though it's on a flat surface.
How do you know that surface is flat? What's it?
The surface of the ground right here that we're taking a picture on.
About the,
wow.
Have a question about the photograph that I put up?
I already addressed it.
How so?
So I'll do it again. It doesn't appear the same every day.
How
It's
much
nothing
does it
more
vary?
than it's nothing more than an apparent location.
How much does it vary?
In addition, I just now showed a meme where you can practically demonstrate objects on a flat floor will appear to go down and away from you due to perspective.
I don't care about your meme. I'm talking about the photograph.
Oh, you don't care about practical demonstrations.
No, I'm not. I'm not interested in your meme.
Oh well, here's
I'm
the deal.
interested
His
in
claim
the
was this can't
presentation.
happen
You
on.
asked me to put up a presentation,
And it sucks.
and
So your
there
claim
it
was this
is.
couldn't.
Now,
You're not listening,
tell
dude.
me how much it would vary.
Okay, your claim is this couldn't happen on a flat Earth. Yes or no?
Yes.
I just showed you that on a flat floor it can appear the same way. What's your response?
You didn't.
I did.
Well, I would say
Even
I would respond to that with the same response as I had before. You're now saying that you have no way of visually determining if the Earth is flat or curved, because you're saying it can be flat and appear that things are curving down away from you.
Y'all's claim. You're actually the truth is your claim. Oh, there you go.
You're now saying
your claim is that you don't have any physical evidence because you can never see the geometric horizon. But then clowns come around posting a picture that they claim shows the geometric curve right after they say in the debate right before it that you never see the geometric curve. Welcome to 2020, guys. Welcome
How much
to
of an error is there?
Welcome to Flat Earth.
How much of an error would you expect to be in that photograph due to geometric versus apparent horizon?
Well, are you claiming the causation of what we view Earth curve or no?
Yes.
Okay, that's your
So
claim.
How much of an error will there be between the apparent and the geometric horizon on that photograph?
There is no geometric horizon. That's your claim.
If there was one,
There's a geometric horizon.
If there was one, I don't know because I go back the next day and it'll look different.
By the apparent horizon.
If I go back the next day, it'll look different. You cherry picked out of 450 of them, and you think that means there's a ball. That's pathetic.
I just picked one at random that had a
No,
nice
you
picture
didn't.
in it.
No, you didn't, Soundly. You've only stamped
I'm
your
not
name on like 2 or 3. Oh, I'm sorry. I'm not looking. My bad. Well, I thought it was Soundly. Okay, well then maybe you're different. I'm sorry. Then don't invoke Soundly's, please. You said you had it. You said something about a horizon, but the thing about it is the horizon is an apparent location.
I never brought them up.
Someone else that said they were bringing a picture, they said the word horizon.
I think you got a bit mixed up with it. This picture is by Jay Tolan Media. He's a flat earther. Okay.
So go ahead and tell me.
Wait, which one? Okay, which
how
one?
much of an error the apparent versus the geometric horizon will
I'll
get?
presented.
Okay, so I put that thing up there. Why don't you give me an idea of how much of an error you think a geometric versus an apparent horizon will give?
Can you post the picture again, please?
Dude, this is the thing.
Just
it is
so
your
that people
claim
in the
that
chat
there's a geometric horizon, bro. And your
No, that's
claim
just
is that we
geometry.
don't ever.
Go ahead
Well,
and click
if the Earth's
that.
a ball, yeah. If the Earth's a ball.
Go ahead and
You have
click
to cut me
that
off,
and
dude.
have a look. Go ahead and click that and have a look at that photograph. You can even stop the video
I don't
right
have
there,
to.
and we'll go ahead and talk about the photograph.
I don't have to though. You know why?
No, you don't.
Because you're claiming, you're making an additional claim to what we perceive, what's apparent. You're making an additional claim to that. You're claiming there's
No, I
something
asked you-
physical there, and then you're cherry picking. You're cherry picking an apparent perception, and then telling me that it's actually physical.
All right, tell me what the difference between the apparent and the geometric horizon is.
The geometric horizon doesn't exist. That's your fairy tale you believe in. Please stop trying to put it on to me. I don't have to answer questions about it. You tell me, dude, because that's your claim.
There's no geometric horizon, bro. There's none. We've looked for it. We can't find it.
Well, do you find it interesting that he claims you're cherry-picking a photo when it was one specifically cherry-picked by a flat earther to show no curvature?
Well, no, it wasn't cherry-picked. It's just that it was an impossibility. So that's why it's important.
Why the hell did you say it was cherry-picked?
It's not. Do you know what cherry-pick means?
We're wondering if you do.
Cherry-pick mean? What does cherry-pick mean?
You literally.
What does
just said Bob
cherry-pick mean?
This photo.
What does that mean?
Literally.
Googling
Are you
it.
going to acknowledge that you said Bob cherry-picked this
Yes,
photo?
I did say that. Do you know what it means?
Now, Bob did not cherry-pick this photo.
Did you know that? Did you there? Did you watch it yourself? Sorry to interrupt. Sorry.
This is what Jay Tolan presented as his proof. This is the photo from his video. That's not a cherry pick.
Okay, yeah, I keep
Proof of what?
mixing up with the dude who said he had 450 observations himself that he did that he was about to present.
I don't
think I was going to present all 450 of them.
Well, I just said pick any
pulled
one. I
at
said
random.
pick out whichever one makes you happiest that you did, and now you're showing me a flat
Okay, I did,
earther's
so?
picture.
your
A
point?
flat earther's picture. So you didn't do it. Okay, well at least we got that covered. You
Oh
made
my
that
God.
bullshit up.
So
So what?
analyzed
Well, I'm just saying, don't say it then. Don't claim it's weird. Okay, someone claimed that they personally did the observations. No.
Yeah.
Someone claimed they
Are
did
you going to
450 observations.
look at the photo and discuss it, or are you just going to continue on with this? word
I've
salad?
already discussed it, my
No,
friend.
we're
Word
talking
salad.
about- all right.
The horizon is an apparent location where the sky appears to meet the ground. It constantly fluctuates. It's nothing more than an optical phenomena. You and your model and your allegiance to this model makes an additional physical claim to that, a geometric horizon, a geometrical necessity of the radius you claim of the Earth that we live on. You're making a physical claim additional to
Very
the
good.
appearance. So please stop conflating the appearance with your physical
What's
claim.
the difference between the two? How much of an error
One
is in the
exists and
apparent
one
horizon?
doesn't. One we actually see all the time. One we never see anywhere ever. That's funny. Yeah, no, I agree.
So would you agree then, Witsit, that we cannot determine the shape of the Earth by looking at the horizon?
Well, I don't make a claim to shape. We can determine if the Earth's curving.
How though? If
well, there should be a
if you-
physical curve no
but
matter
you-
what.
But you've
It can't move.
described- Hang on. But you've described the effect of things appearing to slope away from us or curve away from us, even though the Earth is flat. You say that it's possible for things to appear to do that.
Well, we can demonstrate that. Can you demonstrate that on a globe Earth that something would get loomed up over a mile to make it look flat? Can you practically demonstrate that?
Hang on, I'm getting somewhere. So if you're saying that things can appear to curve away from us as if they were curving away from us, but they're actually not curving away from us, they're flat, how can we determine from observations if the Earth is flat?
Well, because the observations constantly change, but the physical Earth curve would never change.
Right, but how would we know what the physical Earth curve is, though?
It would
We
never
wouldn't-
change, my friend. It'd be there
Right,
always. That's how
I
you'd know.
understand it would never change, but how would we determine what it is? If we couldn't determine it from observing, you're now down to some sort of physical measurement, I assume.
Well, yeah,
With
I
the
mean, y'all,
laser shooting through it.
ironically enough, y'all started with just looking at the apparent location, but yeah, you can't do that. You would have to do it some other way and then try to compare. But what you would know, if you do have the R value, which I'm giving you that presupposition, if you have the R value, which is founded on apparent location, but regardless, I know you have contention with that. Say geodetic surveying, you got your R value.
Hold on. I don't know where you're going with it. All I'm asking you
I'll
is
make
if you agree with me that we cannot, just from observations of the nature that we're talking about, we cannot determine if the Earth is flat or if it's curved.
No, because we would have a physical obstruction of Earth curve that doesn't change.
So can we or can't we?
We
With a
could,
laser
yes.
shooting through the hump.
We can, just from observations, we can determine if the Earth is flat.
Well, we can determine there is no physical obstruction of curve there, yeah, because it can't move.
But how? But if you've said
I
that
just
it's
said-
flat, well, you said it. You also said though that it's flat and things can appear to be sloping away from us.
Okay.
So
that's non sequitur to Earth curvature causing physical obstruction that doesn't move.
How do you know that that sloping away from you isn't curvature?
Because it's on a flat ground.
But how do you know that the ground is flat if it's appearing to curve away?
Because if I go back the next day and it isn't in the same location, it isn't a physical Earth curve that's obstructing the view. It's an optical effect.
So how do you know it's not an optical effect that it's flat? How do you know? Well, look, what you're saying is, sometimes I see it curving away from me, and sometimes I see it flat. And I know that the curving away from me one is an optical effect. How do you know it isn't the flat one that's the effect?
Okay, once again, there would be a physical obstruction that doesn't move at all. So the difference is we can show it appear to curve on a flat surface, but we can't. But we know that there's a physical obstruction.
Why does it appear to curve on a flat surface? Why does it appear to curve?
Because of perspective.
Hold on. If you
How
go
is that
back,
funny? We can practically demonstrate
because
it.
you're saying it changes from day to day, so your perspective
yes, it
doesn't
does.
change from day to day, does it? How?
Yes, it literally does.
How? The thing would be the same distance away.
What you
would have the
perceive,
same
what you perceive changes hour to hour and day to day.
But as a result of perspective.
Well,
or as
your
a result of
perspective is
something else?
relative to that, obviously, dude.
What?
Your perspective is relative to atmospheric conditions, obviously.
You say the appearance of things changes hour by hour. Is that a result of perspective, or is it a result of something else?
No, that is your perspective that is relative to.
So
the
your
change.
perspective. So if you stand in one spot, you look at a building, 5 miles away. If it changes in any way, that's your perspective changes.
No, you straw man me
you
again.
haven't moved.
So when you're at the
Well,
same
I'm asking
location,
you,
you're.
is it an effect of perspective, or is it an atmosphere?
I already said no. I already said that it's just your perspective isn't changing, as in your angular resolution. Of course, your perspective doesn't change, but it is relative to the changes within the atmosphere.
So I still don't understand how you can determine that the Earth is flat from looking by making an observation, because you say, oh, because there's no obstruction and there should be a physical obstruction, but at the same time you say the physical flat Earth curves away from you.
No,
so
it doesn't
how
curve
is
away
it,
from you.
or appears to curve away from you?
Yeah. Okay. So
Right,
based on certain.
So how do you know how do you know that it isn't actually curving away from you?
Because
but just appearing to be flat on the times when it's flat. How are you
Because-
deciding which one is an illusion and which one is physical
They're
reality?
both illusions.
Right. So you have no way of distinguishing whether it's flat or curved then, because
Well, unfortunately for you, that isn't
describing
true.
You're describing it visually appearing to curve and visually appearing to be flat, and you're saying both of those are just illusions.
Well, yeah, because we're always only seeing the appearance or the apparent location relative to atmospheric conditions. But the problem for your side is you're making an additional claim to that. You're not making an apparent claim. You're making a claim to a physical location. It's
Well, no,
entirely different.
What, the flat Earth isn't physical?
We never claimed the horizon is physical, dude.
But
Can you tell the radius of the Earth without
the
looking at
Earth
the
is
horizon?
the Earth. All of the Earth up to the horizon is physical, right? And all of the sky up to the horizon is physical.
The horizon is just the furthest that you can see along the flat surface that you're standing on. It's the furthest that you can see when the two zones of vision, top and bottom, merge, and you're on top of a surface that is limiting the bottom half of your vision. Eventually, it will ramp up into your eye level and merge into a line. That is all. It is not physical, and that's something that's actually physically ramping up.
At the end of the day, Whitsit's telling me the flat Earth sometimes appears to curve away from him. It sometimes appears to be flat. He has no way of distinguishing which one of the two is an illusion, and in fact, they're both illusions.
And you claim that there's a physical.
Hold on, I'm still talking. And yet, he can still determine if the Earth is flat or curved by making observations.
Yeah, void of physical
that
obstruction.
makes any sense.
Void of physical obstruction.
Which wouldn't be there if the Earth appeared to be curving away from you, an effect which you have described.
But it isn't always there.
Like train tracks. It's not ramping up to your eye level. It just appears to be doing optically. It's just a 2D representation of a flat plane.
Again, you're arguing the same thing, Lemon, with no way of knowing. It's all that we just.
No, that's
we'll
not
never
true because
ever be able to determine this
Jim,
from observations. It's
Jim,
not
my friend, this is why this is not true. Okay, you are conflating this and misrepresenting.
How am I?
The reason that isn't true is because you would be able to observe it if it were a ball. And the reason is there would be a physical obstruction that doesn't move anywhere it's consistent. But we never see that. Now you're just kind of scooping that in there with
you claim there are atmospheric effects that change things. Why would they not change things if the Earth was spherical? Why would
because
that
the physical horizon doesn't change.
Why?
Because the Earth isn't changing sizes.
Right. The things that make up the physical things on Earth that make up the physical horizon that we see.
It isn't a physical horizon. What are you talking about?
Well, because it's made of physical stuff.
No, it's literally.
If I'm looking at the ocean, if I'm looking at the ocean, everything up to the line of the horizon is ocean. That's physical.
If you go out to the horizon, can you touch it?
Everything up to that line of the horizon is also on the above is sky. That's physical.
Can you
go to actually physically ramping up?
Both of those two things are physical.
But they don't physically meet where they appear to.
Right, so you have no way of...
That means it's just an apparent location that's not physical.
So we have no way of determining the shape of the Earth by making these observations. That's your argument.
Well, we can falsify that the surface is curving. We can falsify that the surface... We can falsify that the surface of the Earth... We can falsify that the surface of... We can falsify that the surface of the Earth is curving. That isn't synonymous with a shape claim.
How would we... From observations? When you're telling me that you can look at a flat Earth and it appears to curve away from you, but apparently you have a way of knowing that that isn't actually the Earth curving away from you.
Because the next day it won't be.
But again,
how about we take the apparent out of it?
How are you distinguishing which one of these observations is the illusion?
Once again, they're all illusions.
Okay, so again, if every observation is an illusion, how are you able to determine the nature of anything physical from it?
Well, what we can do is falsify physical curve. I don't know if you're listening or not.
How would you, from an observation, you can do this?
Because you would observe a physical obstruction.
But that would be an illusion. That would be an illusion. All observations are illusions. How? You've just told me that all observations are illusions.
Yeah. Imagine
how are you able to
being
determine from
in this
this
position.
illusion what the physical reality is?
I almost feel bad.
We already have precedent.
Look, you're saying you're the one that said all observations are illusions, and then you're saying to me, but by making an observation, I can determine from that illusion what the physical reality is.
No, every horizon
you don't make
is...
sense, dude, not me.
Every
You're
horizon...
the one that needs to have people feeling sorry for them.
Every horizon is not optical, my friend. I mean, every horizon is simply optical.
Okay, so how do you determine which ones are optical and which ones aren't?
I clarified. I said every horizon is nothing but optical.
Okay, that's again, you're saying it's all an illusion. Every observation is an illusion.
No, why are you saying every observation is an illusion
that's what
when
you
I
said.
very
That is specifically what you said. That is
I very specific. I very specifically said the horizon, and then you, for the fourth time, recollect my point by saying all observations.
Well,
that is not what I said.
I'll put to the point to you again. We'll just go back round and round in fucking circles.
Just try to understand.
You said the Earth can appear, even though it's flat, it can appear to curve away from you. And sometimes it appears to do that, and sometimes it appears to be flat. And I said to you, how do you determine which one of those is the reality and which one of those is the illusion? And you said they are both illusions.
Yes, you cannot determine any physicality from an illusion.
Right, that's what I just said. But
welcome to Flat Earth, Jim.
But you're claiming that you can determine.
just try and listen.
No, I'm
listening. Ronnie, stay out of it. He has said that he can determine the shape of the Earth by making an observation. And now he's just literally said you cannot determine physicality from making an observation.
Yeah, you can't use
which is true. Can you determine it from an observation or not?
You can't take the apparent location and conflate that into a physical location, but your claim is that there is a physical location.
Well, so the flat Earth isn't physical then?
What we see as the horizon isn't physical.
So how are you determining then what the physical nature is if you can't see it?
There is no physical nature, but you're claiming there is a physical nature. You're claiming there is a physical nature. I'm saying that there isn't a physical nature. Would you like to provide evidence? Because all evidence supports what I say.
Right. Okay. So you're claiming that the Earth that you live on is not physical.
No, another shot, man.
And we both live on a physical Earth. There's no difference between our claims on that. You claim that the Earth that you live on is physical. I claim that the Earth that I live on is physical. We are on the same place on that. I'm not making some extra claim about physicality that you are not.
Well, you are,
your
though.
Flat Earth claims are about a physical flat Earth.
Yeah, but your physical claim is different. It has a curve, and so then
yes, and yours is flat, and you say that sometimes your flat one appears to curve, but you know it doesn't actually curve because what? You have no way of determining between the two things. You've agreed yourself that they are both illusions, and yet apparently, and you've also said you cannot determine the physical nature of things from something that is just an illusion, and yet you are doing.
No, that's what you're doing. So you're claiming that there's a physical obstruction.
I'm not. I say that we can determine the nature of things by making observations, and that's how I determine it.
Yeah,
I'm logically sound in what I'm saying.
No, you're not, because you're claiming the apparent location can show you a physical obstruction proof.
I'm saying it can easily show you within a reasonable margin of error, as the Bob was saying.
Boom! All right, glad we finally got there. We can move on now. So it's just an approximation based on apparent location. It has nothing to do with the physical obstruction.
Isn't
How about we take out the apparent location?
That's just idiotic nonsense that means nothing.
How about we take out the
There's no boom there, is there? We can determine a location within a reasonable margin of error. Now, you can just dismiss that as an approximation based on apparent location, but that doesn't make it not useful to us. It doesn't mean we can't determine that within a reasonable margin of error.
It's not useful to me because it's bullshit.
That means it can't be without that reasonable margin of error, and that means if we measure it to curve, it curves. It doesn't mean the observation might be slightly wrong and it's flat.
No, what it means
I say we can determine this. You say you can't.
Yeah, you're right.
So you don't know what the shape of the Earth is, like you don't know how far the sun is, and you have no way of knowing either of those things.
I don't make a claim to shape for the 10th time, but the surface of the Earth isn't curving, and the way you know this is because if it were in fact curving,
you don't know that.
It would cause this physical obstruction, and so what that would mean is there would be a different horizon. It would be called the geometric horizon. It'd be a physical Earth curve that blocks your view, and how soon you see that Earth curve would be relative to your height above the surface, right? Because of the tangential drop of the spherical assumption. Yet we only see the apparent location of a horizon. We can never, ever find a consistent physical obstruction known as the geometric horizon. You're making a physical claim additional to the apparent location.
Again, you live on a physical Earth, I live on a physical Earth. There is no difference at all between our claims with that in that regard. The ocean up to the horizon on your Earth is physical. The sky up to the horizon on your Earth is physical. All of that's physical. I'm not making any claims different to what you are. So don't talk bollocks.
Yeah, you're claiming that there is a physical horizon. I do not claim such lunacy.
Is there ever a time anywhere on the Earth where the sun or the moon isn't obstructed at some point?
Why are you talking about the sun and the moon?
Because they're objects that we observe every day.
We see things in the sky.
In our reality.
Yeah, they go over top of the geocentric stationary plane.
Okay, and we can't use them to determine anything about our reality because
We
what?
can't use them to prove any claim about the terra firma.
It's just a coincidence
Can we
that
use
the
them?
behavior. So, is it just a coincidence that the behavior of all these objects behave exactly as if it were on a sphere in the heliocentric model? It's just a coincidence that they behave that way, but they don't
No, of
actually
course
behave
not.
that way because of unknown reasons, right?
No, of course not. It's not a coincidence. The heliocentric model was formulated after that was observed.
Right, but no, I mean you can map this stuff out as if this was all happening in the heliocentric model. You know, a sphere with objects moving around it, and it works just as if that were
Because
the
it
case.
was made
But you're
after they
saying-
saw that.
So okay, it doesn't matter if they made it. What does
That
it
is
matter?
correct.
What does it matter that they made it
What's
after they
stopping
saw
you
it?
from doing the same?
They
on the
modeled
floor?
it. They modeled it after they saw it. So
Yeah,
what does
but
that
you
actually
can't
mean?
tout. You can't tout
They made
predictability when it was.
You're
observations.
agreeing that model was made to match reality when you say that.
I agree that it was a
You
theoretical postulation of a model
proved yourself
formulated
wrong.
around
and it happens to
reality.
behave, and it happens to behave
If that,
in a
if
way
that
that
helped
it
predict
was.
your cognitive dissonance, you run around
guys,
doing that
take it
stupid
down a
shit.
notch.
Wait, time out. Can we get a basic concession here? There's a difference in prediction and post-diction. If the model was formulated after we saw the sky in a reoccurring pattern, that does not then allow you to tout predictability 400 years later. That's literal
Haley's
lunacy.
comment. Haley's comment was prediction. They predicted
said
it 70
sure it
years later, and
does.
it came.
I did.
Oh yeah, and it was Haley's comet ever visible before the last time?
Yeah.
What about the time before that? What about the time before
Unpredictable
that?
nature. They didn't know. They didn't know the exact location or the exact time on
Do
when
they?
it would come.
Are they? Does it behave in a cycle?
Yeah.
Oh, okay.
Yeah.
So
but
next.
they predicted when it would come back to the exact second, and the exact
okay.
location.
Yeah. Cool.
All right.
Yeah, using their models for
No,
gravity.
using the relative movement of the bodies in the sky. That's all they did. So you're presupposing sphericity and distance is relative to us. Y'all can't even listen. Y'all can't even listen, dude. Your worldview's getting dismantled. I'm sorry. I know it's a tough red pill, dude. I didn't make the.
You are amusing.
What's the internet
How do you
question?
tell the
dude?
radius of the Earth without looking at the horizon?
Well, are you willing to disavow that is how it was originated?
So because
let's just say yes. Is there another way to
hold on.
calculate the radius
Oh,
of the
okay.
Earth?
I don't know. You tell me, man.
I'm just curious to know how this logic works. So if you observe something and then you create a model to predict it after you've observed it, and then that model is able to describe the behavior.
We could
you're saying
already
that that's not a
describe.
valid
We could
way.
already describe the behavior before the model, my friend. It's
No, you
reoccurring.
can't. No, there's no
Yeah, we
flat Earth
literally
model
can.
to describe. There's no flat Earth model to describe what we talked about before about the sun's
Dude, it has nothing to do with
ground
being a
speed.
flat Earth model. We're talking about
But
the
you
sky
just said
reoccurring in
earlier,
a pattern.
There is no flat Earth explanation for why the ground speed is the same when the sun is over
I did
the
not say
tropics
that.
of
You're
Cancer and
lying.
Capricorn.
Now you're imploding and diverting back to something
No,
else you've
that's
invoked a
exactly
straw
what
man
you
about.
Then what's the explanation? What's the explanation? Hold on a second.
Hawaii?
What's it? Then what's the explanation? What's the explanation for why the ground speed is the same for the sun over,
I already said.
over the flat Earth?
I said, yeah, you're assuming that since the apparent location doesn't change, or the ground speed doesn't more so, right? The perceivable light on the Earth, and that it would have to cover more ground, that it must be impossible because it is going a constant speed. That is an assumption that you deduce based on the ground speed that the sun is in fact going the exact same speed.
Whoa.
We don't know what
Well,
it
you
does.
can
It could
measure-
actually
you can
even
measure
change
it. You
altitudes
just
and
admitted-
it
you
could
just-
change altitudes and distance relative to its circuit.
But
You
you-
don't know.
The altitude wouldn't have anything to do with it because we're talking about when the sun is directly overhead. So the altitude is irrelevant. Whether it's a mile above your head or a million miles above your head, it makes no difference. So you said earlier that we can.
You
we
don't
can't
even
measure
listen
the
to what
apparent-
I say before you respond, dude.
You said, Witsit, you said that we can measure the apparent the ground speed of the apparent position of the sun. We had that conversation an hour ago, and you
Yes,
said
and I
yes.
just explained to you
we
that
can
if
measure-
it was going.
Go ahead. Go ahead.
Okay. My response to what you just brought up, which was actually the version, but anyway, it's that if the sun was increasing or fluctuating in altitude, also fluctuating in speed, right? There would be a sweet spot where.
Did he go for everyone or just me?
He disappeared
for everyone.
Oh, dang.
You know, the thing is, there's many different ways to calculate the radius of the Earth. You don't have to use the horizon. We can measure distances across the ground.
Oh, geodetic surveying.
We can measure things with the sun directly overhead to find the circumference of the Earth.
No, you can't.
And
Did you just
that's
invoke
not an apparent
Aristophanes, dude, in 2020?
He didn't. You're straw manning.
Well, that's what he's talking about.
No.
Hey, what's it? Look at my stream. When are you guys gonna have one of these things?
None of us are Eratosthenes, but we can do that experiment and then some any day.
Too bad that doesn't prove shit. Too bad that doesn't prove shit.
Sure does.
No, it literally doesn't, dude. Y'all just sit here and lie about shit? Is that what y'all do?
Literally proved the Earth was not flat.
You think Aristophanes proved the Earth was a ball, and that shows where you are.
Eratosthenes knew the Earth was a ball.
They didn't know shit.
The radius of the ball.
Okay, do you think Aristophanes... Wait, did Aristophanes himself definitively prove one way or the other regarding the Earth?
No.
He wasn't attempting
Thank you. Okay, fair enough. I assumed you weren't going to be honest.
I, on the other hand, did prove it one way or the other.
He didn't set out to prove it. What he set out to do was to measure the radius of the damn thing.
I never said it. Why are you strawmanning me? Did I say he set out to prove it? I said, does it show one way or the other?
Yes, and when I repeated it,
no, it doesn't. That's a lie. Even Neil
other.
deGrasse Tyson says you're a clown.
What? I don't even know the guy.
Even Neil deGrasse Tyson says to say that he said it works on both models.
What he actually said was,
if you had a third spot, then it won't work. That's what he said.
1 second.
I had a third
spot. I haven't said anything in a very long time. No, he did not say that. What he said is a 2-point Aristophanes experiment does not prove that the Earth is a globe. However, if you use 3 points, it definitively proves it. That's what he actually said. So why don't you admit that? And
I just said it before you did. You just weren't listening. I already said that. You just weren't listening.
You didn't say that.
Okay, is this being recorded yet?
Say that. I told
is this being recorded yet?
I did.
We are recording it.
Okay, so it was recorded. I did say it.
He did or he didn't, and I'm not. I don't care. I'm not going to hold him to that. If he says he does, I'm cool with it.
I said, yeah. If he has a third point, he says it would only work on the globe. I said that, but we actually have demonstrations where we have 3 sticks and the shadows are the same.
Hold on, one second. Now listen to what Dr. Bob did.
We did it with 3 points. We had the equator, we had Tennessee, and we had Michigan, and we definitively proved that the Earth was not flat. So we did a 3-point Eratosthenes experiment. If you'd like to see the video, I'll be happy to put it up. Blue Marble Science, and I did it.
Oh yeah, please post Blue Marble Science.
I'll post mine. I can do that. I can play your little game.
I mean, you said that there's a flat Earth explanation for all this stuff, Witsit. But
yeah, divergent rays. Dun.
Like I asked you, well, how is it that the sun rises? Like we asked you, how does the sun rise in the southeast for observers in the southern hemisphere? And you said, oh, they don't know what direction south is. Basically, right? That's what you said. They don't know what direction south is.
Strawman shit.
Was that not what you said? You said that they don't know what their relative direction is. That was like, I think, word for word what you said, which means that they don't know what direction south is, right?
No, I said that their perception is relative to their location.
What does that even mean?
Those are all like 7th grade or lower words, so you should be able to figure it out.
I understand every word you said.
The perception is relative to their location. Is that a way of saying that like they're in a VR goggles kind of reality where every person has their own individual VR world?
Do you just like, yeah, everyone's perception is different, yeah.
The thing is, the ground appears...
He's using more words to say personal atmospheric dome.
Let Miles get in if we can. Do you mind?
Sorry.
Have another go, Miles. No,
it's all right. I was making one point about that rather childish comment about 7th grade words. I listened to that sentence. I understood every word in the sentence, but I did not understand the meaning of the sentence because it was just a word salad.
Perception relative to locations word salad. Well, great to see where you're at on the spectrum here.
Thank you for confirming his point again.
Can you, while I'm in and talking, can you give me an example of 4 cities on the Earth that are several thousand miles apart and distances between them known that map onto a flat plane?
That wouldn't happen due to perspective. Yet again, the angles that you draw due to perspective are inaccurate because parallel lines appear to converge to the perspective, messing with the angles that you would draw and the distances that you would derive therein.
Whether you could do it. Can you do it or not?
If you just hand wave dismiss everything as word salad prior to hearing the explanation, then you're useless in any form of intellectual
I asked the
forum.
question, can you do it or not?
He was fucking answering your question,
he
dude.
wasn't, because the answer to can you do it or not is yes or no.
The answer is no because of perspective, with parallel lines appearing to converge due to perspective and messing with your angles. No, because of perspective over a flat plane.
Now, we all heard him answer your question. Now, here's where you act like you didn't again. Go ahead.
Can I speak now? You can't do it, but every city, every 4 cities, any 4 cities you care to choose that are several thousand miles apart, will all map onto a sphere.
It's because a sphere has huge wiggle room and a huge air factor. You can map anything onto a sphere anyway because it just diverges out, lays out, and just goes anywhere in space. It doesn't converge to a point. It just tries to take the lack of perspective and the refraction that we have over a flat plane and approximate it over a globe assumption. That is all.
It maps precisely onto a geoid that is almost perfectly spherical. You can map any 4 cities onto that surface. You cannot map those 4 cities onto a flat plane. On any flat plane.
That's because a sphere expands ever outward in space. There would be no triangulation because it would just expand ever outward in space and you'd have huge wiggle room. That doesn't prove anything.
The geoid is a precisely known size and shape.
There's the Eratosthenes video you asked for, by the way.
Miles, can you double check and see that I'm not going crazy? Did Lemon just say that perspective changes the distance of known locations on a flat plane?
I have no idea because Lemon just throws words
triangulating to the sun, so you're changing the subject. You're triangulating to an object in space without any sort of real physical marker in space to check your distance at all. Due to perspective, it would raise and lower dramatically, messing with your angles and messing with your distances.
All right, well, there's the video on Eratosthenes you asked for, Jim. Given the fact that there were 3 points, it does not match. It is incompatible with a flat Earth.
Planes fly between all these cities using those distances and always arrive in the right place. Strange.
That's the other, that's why you can measure the radius using a number of other means that don't include anything apparent. You can measure the distance between those 4 cities. You can use a sextant to measure a location on Earth. You can use, in fact, great circle courses are the shortest distance between any 2 points on Earth, not straight drawn lines on a map. There's quite a few different ways that you can do it.
Wow. So you think that was a slam dunk?
That pretty much is a slam dunk, yeah.
Okay.
Yep. Welcome.
You still haven't answered the basic question. What is the error between the radius, the geometric radius calculated by those means, and the radius calculated by the apparent horizon? How much of a difference is there?
Yeah, you do realize the model is already be built off the R value, right?
You can determine the R value.
So you have to apply any aspect of
the R
that.
value from the measurements.
If you have to apply any aspect of the math, if you have to apply
you still need to answer the basic question. What
well,
is
you
error?
You can't not interrupt.
The geometric radius measured by
Dude,
those
I just sat back on my phone and
geometric
listened to you talk this whole time.
Apparent horizon.
All right.
Okay, so
let
yeah,
him go
to
respond
have
to
a standard of comparison of a physical R value, that's what I'm asking you, right? So you agree you can't just take a parent location to get that because you have no standard to compare it to.
Yes, you
And
do.
I'm saying that the entire. Okay, what
You must
standard?
definitely have a standard to measure it against. and you can
Nowadays,
calculate an
sure,
error rate.
you can say that nowadays. But my point is that when
Okay,
it was
well,
originally
today is
come up
today.
with, but the model was built a long time ago.
So what?
What do you mean? So what?
So it had errors in it. It wasn't perfect.
Out of date, man.
Yeah, so
Better
y'all been tweaking it for hundreds of years. Of course, it's better now. It's
Yeah,
a
so?
working model
Oh,
that
you know what?
make
You know what?
post diction.
I said this. I said this earlier. I
Admit
said
the
this earlier.
spherical
That
Earth
you've had
model is getting better and better and better. Thank
It's
you.
getting better
you've had
within
it-
your
great.
presupposed fairy tale world that doesn't work. Why do you have to keep fixing it so much?
Give
They
me
can
one
get. They're trying to
example
fix the
of why
holes.
it
They
doesn't
keep trying to
work.
fix the holes in it. She fix the holes in it.
All right, what?
I already said this earlier.
You still, you
I've already said
can't
this. Hold
keep
on,
dancing
man.
away
Calm
from the
down.
question. What is the
No, I'm not.
error between
It's a crap
the
question.
apparent horizon
It's crap.
radius and the horizon?
It's very
radius
close.
Of the
It's
Earth
very-
is determined
it's-
by other means.
It's
don't
very
involve an apparent
close. The
horizon.
perceived horizon, if you were to take like an average, it's very close with like
What's the error
your
rate?
natural. Stop, dude. Your natural angular resolution of your eye. It's very close, and that's so they are actually very in the same ballpark. So that's why. That's actually why. Because of Alberuni. Dun dun dun.
Wait, explain what you mean.
What are the
explain
differences
what you mean
between
that
the two?
it's near the angular resolution of the eye. That doesn't make any sense when you say it like that.
Yeah, well, with
No,
our
it's utter
our
nonsense.
eyes, we have a certain angular
What?
resolution, and we don't.
Listen, are you going to answer the question? What is
I'm trying
the
to,
error
but you
rate
just have to
between-
keep interrupting me.
Bob, I
Right,
think he
stop
did.
talking. What's it?
I think he did answer the question. He said they're very close.
Okay, it's 1 to 5%, and the bottom line is both are still a radius. What's the
Okay.
radius of a flat plane?
I made this point earlier
don't
anyway that the
know
globe
the
model,
rate. I
for
don't make
example,
radius claims.
most people around the world have been fucking, working on the globe model. So what if it's a bit more accurate at the moment? Give Flower some time. We'll construct something. Hold on,
You've had
let me
the same
finish.
amount of time.
Let me
You've had
finish.
more
Never
time,
bad.
actually. Romy, you've had more
Still the globe,
time.
man.
No, because you're all thought it was a globe. Because when you went to the horizon, you saw that what apparent curve of boats going over the horizon, and everyone got it wrong. So everyone's built their whole world's assumptions from that mistake. Whoever was at that shore
But why?
watching boats go
But
over the
why?
horizon.
If it's actually flat, and people at that time originally believed the Earth was flat, you've had longer than we have. There's no reason why that idea would become established just because somebody said it was so.
Yeah, they claim they
got
went
it
to
wrong.
space.
They got it wrong.
So what?
No,
They
so
lied
why-
and claimed they went to space, dude.
But if everyone, well, I mean,
Boy, you've got a
that's
whole
another-
bunch of
that's another-
fantasies, don't you?
You
Yeah,
have a
that's
fantasy
another-
that people went to the moon in '69, dude.
You
Jesus
have a
Christ.
fantasy that
shut
doesn't
up.
work.
You sound like a boomer. Are you a boomer? We went to the moon, damn it. Like, shut up.
we can
I
show
saw
that
the
to be
rocket
true with the
launch.
mountains of evidence that support the thing that happened, like we can with any event in history. What makes
friend.
this event? What makes this
Personally
event?
saw
Wait,
Apollo
what-
17
what did we
launch.
gain
Hang on, I'm
by?
still talking. What makes this event different, as historical events go, is the amount of evidence supporting it is massive and
That's
comes
not
from all over the place. Well,
No,
it
that's
is
not
true.
Okay, where's the telemetry data? That is the actual evidence. That would be the most important, valuable evidence of anything
Well,
ever.
why?
So, do you have it?
Well, why would it?
What
I
does
mean,
the
Do you
telemetry
have
tell
the
you?
telemetry data?
what is the telemetry data? What do you think?
What
that
is
are?
it?
No, it's just all kinds of different data about the travel.
About what?
Them traveling.
I mean, basically, what that telemetry data is it tells you what is going on in the spacecraft at that time.
Yes,
So-
and them
We have plenty of
traveling.
telemetry from the Apollo missions.
So it'll
Okay,
tell you-
please provide all the telemetry data then. Because it's MIA and we all know it.
So hold on, when we do
It doesn't exist.
When we
You
do, are
can't.
you gonna want?
lots of it does exist. They recently found a whole bunch of it in Australia. So lots of it does exist. However,
Why the
Oh,
fuck
hang
was
on,
it in
hang on.
Australia?
hang on, because
They
some
were
of-
tracking it there, dumbass.
Oh,
However,
got him.
That dumbass, you're the
Burn.
dumbass. You think the fucking Earth's a globe?
Yeah, and I'm a dumbass because it took 70 years or 50 years to go to Australia and get something that America should have kept right there on a museum on display, saying we're badass. We're the first ones as humans.
For fuck's sake!
We are lying.
It already exists. What went missing were tapes where it was recorded digitally. That's what went missing. All of that data exists. Where the spacecraft were in space, how long each rocket burn was, when any switch on the spacecraft was switched. Everything is already recorded on paper anyway. You could just go to the lunar flight.
No, I'm not going to listen to you after him.
I'm still talking, guys. You could just go to the Lunar Flight Journal and look at all this stuff. It's all there, recorded, everything.
So all the film.
See, here's your logical fallacy. And
wait, can y'all be honest? Is all the film telemetry data gone?
No.
Absolutely not.
And
it's not. Oh my God! See, y'all lie about everything. Did they lose any?
I'm not being allowed to answer the question because everyone from my side has got something to say, apparently.
Let me rephrase the question, my friend. Did they lose any of the data?
Yes, they did.
Do you agree that some of the stuff they said they lost would have been crucial evidence to support that they went?
I think it would have been. I think it would have been useful, but I don't think it's crucial in any way.
Well, it would be pretty definitive, right?
Well, no, no, not in any way. Because if you think about it, every single piece of footage from NASA, every photograph, everything, every frame of footage, you have already rejected as fake
because they lied. Then
now you're saying, if we had this other bit of footage, well, then I would accept it all.
No. Well, what I'm saying is we'd be able to critique it independently, right? And really,
you can now.
No, you can't. It doesn't exist.
Hang on. Or you just have a recording of the recording.
Yeah.
So as that signal was broadcast from the moon, it was stuck on a TV screen, and they pointed a camera at that TV screen. So you are seeing it.
Okay.
Well, you are.
Dude, come on, but can we just level out and be fair here?
It would be great if we had that original recording, but at the moment, we
so
don't.
all the people I know that are globe earthers, I know a ton of globe earthers.
Tell me why the telemetry data is the definitive piece of evidence that says yes or no. What about the astronauts? What about the experiments that are on the moon? What about the original?
It's funny that they say different contradictory testimonies. That's funny to you that people take your money and tell you they went to space, and then they scare everyone with an ideological war. They scared everyone with an ideological war against the Soviet Union, and then everyone believed it.
What?
No, y'all are afraid to let me really make a point. Y'all want the East to make all your points, and then I get cut off.
Can't even be read on modern machines. The critical piece of evidence to you.
Wow, we can't go back either because we just can't recreate the technology. So anyway, what I'm saying is, what about all the globe earthers I know, right? That think flat Earth is stupid, which they haven't looked into. What about all the globe earthers I know that question the moon landing, some of which say there's no way we did that, they lied? Are they also just all crazy?
No, I don't think anyone's crazy. I just think that most people are kind of largely ignorant of the subject. That's what I think. Most people aren't aware of all of the evidence that supports it, and they see a few malformed arguments that question it, and you know, they like the idea.
Did NASA change any of it?
Hang on, nearly there. I think as far as conspiracy theories go, I think this is one that people can sign on to quite easily, because they can, unlike most conspiracy theories, they can see a clear motive for this one, which was winning the space race. So that's why I think it's quite a popular one.
I know, and I think, dude, I think you're right. I agree. But I think that motive that most people will use to justify it is that was actually kind of set up so that you'll think that's the reason. But we do know, if we fast forward 50 years, no one else has done that again. And so that holds to this day to be the time that it was definitively proven the Earth was a globe. Now, of course, that is not what everyone interpreted it as. That's not what the average person looks into as a conspiracy mind thinking. But we do know it was all propaganda bullshit from the Soviet Union and the U.S. from both sides. You can prove it through declassified information. So they, I don't take that motive that was crafted to be legitimate, but I do agree with you. That's the reason the average person would look into it.
What
Sure.
specifically can you prove was bullshit? What are you
Well,
referring
for one, like when the Soviet Union was trying to tell their people that they were going to beat us to space, they were literally just showing them, and you can look into this, they were just showing them like Coke can size bottle models, and they were just taping these little models. Yeah. So they were propagandizing over there about going to space, and then we said we did. Then JFK said we're going to be the first people to ever go within 8 years.
What you mean is they made,
on the 8th year we did it
so that they could explain what they were doing. They made models and broadcast them on TV, like we still do.
No, they told the people that they were real. That was the real rocket they were going to shoot, but it was like a Coke can size model.
Right.
And the Soviet Union propaganda.
You have no evidence.
Yes, actually, there's the dude that lived in the Soviet Union I talked to about it.
Can I ask Jim a question?
Some hearsay. Yeah, go ahead, Mars.
Jim, this missing telemetry, just to get back to that, I was of the opinion, or I understand, missing. And the telemetry from all the others was
no. The visual data and information is missing from all the moon missions.
I think what they did was they taped over a load of these tapes because people stopped making them and they couldn't get them.
Can we agree that's incompetent?
Well, I think I think it's a government.
Shit.
A lot of information coming in on satellites,
you guys, yeah, they did. You guys spend a lot of time complaining about NASA's budget, and this is them keeping to their budget, isn't it? It's them, continuing to use obsolete equipment when it's become so obsolete you can't even buy the tapes for it anymore.
So you would just leave them there. In hindsight, was it incompetent to tape over the evidence of the biggest feat in mankind history?
Well, if we don't know that they have taped over it.
In hindsight, was it irresponsible to tape over the biggest feat in mankind history?
We don't know that they've again. We don't know that they've done that.
You just said that they did tape over some of them.
Well, are you talking about the film of it happening or random data that's recorded elsewhere on paper anyway?
Well, NASA's official claim is that they taped over some of the film.
Because with one, I would agree with you. Yes, that was irresponsible and silly. And with the other, I would say no, that's making good use of public resources, isn't it?
No, good public use of resource would be every single second of footage of when we went to the moon would be available, and it would just definitively demonstrate to the world that we have done what they cannot do.
Footage is available. You can watch it on several different websites and platforms.
Well, what percentage of the trip to the moon can you watch?
You can watch
less than 1%.
Hours and hours of it, mate.
Dude.
And you can watch Apollo 11 in 16mm film as well, because there was a 16mm film camera that was held by Aldrin. He filmed Armstrong doing his egress, getting on the moon, doing the getting what they call the contingency sample. That is a first little sample that he stuck in his pocket in case anything went wrong and they had to abort quickly. And all of that is filmed in 16mm film, which is higher quality than any television broadcast would have been. And then Aldrin puts that on a bracket, that camera on a bracket, and he sets it so it records one frame every second. So it's not quite, film, but it's still, you can still see them moving about, setting up the flag, and all of that stuff you can see in 16mm film.
I'm sorry, but that's fake. It's fake. It's actually fake.
And what
we all know it's fake. We all know it's fake.
Right. Well, you've said that. You don't even.
Do you believe everything they ever said to you, dude?
Hang on.
Did you produce evidence that any of it is fake?
Let me finish. You've made my point. I told you about some footage. You haven't even seen it, and you've dismissed it as fake. But you're telling me But you're telling me if you had this other bit of poorer quality television footage, then that would make it all believable.
No, well, no, it's not. I wouldn't know. Yeah, but I never said that. I never said that. I never said that.
What are your specific reasons for rejecting the 16mm film that I've just described? Why are you rejecting that as fake?
Okay, because, and I'm sure y'all will act like this didn't happen too. As fucking weird as it is, but NASA had these pictures on their website for a long time. They ended up changing them. We actually even used a Wayback Machine to show that the pictures themselves have been altered on NASA's website. So I don't make a habit of really just blindly believing whatever they show us.
So what you're saying is then that you ought to, because of these pictures, this separate thing that Rob Skiba did, because of that, you reject everything from NASA on that basis.
Well, no, not necessarily everything, but
okay. So what things from NASA do you accept? What video and photos do you accept from that?
Oh, videos and photos? Yeah, probably none.
So none. So
easily faked. Would you agree that it could be faked?
So what you're saying is,
could it be faked, Jim?
So what you're saying is that by default you reject all video and photos from NASA. However, if you had this other bit of video from NASA, that would change your mind.
No, it wouldn't change my mind.
And you wouldn't, if you had that bit of video,
it wouldn't change my mind.
Can I ask a question?
Why did you make any point about it?
It's going on for ages.
What way does it change? In what way does it change? No, I'm speaking. Why are you trying to ask a question? Why are you trying to ask a question when I'm speaking, I wonder?
Because we want to talk about fake NASA photos. I'll show you.
Not in a supermarket.
Fake NASA photos.
I want sweets.
Fake NASA photos. I can give you one.
Go on then.
Look at the star trails of the International Space Station.
Oh, fuck.
And they do. Well, from what I've read,
explain yourself. Think about it.
I will explain myself. So while that's spinning around, right, to cause, when it's spinning around the Earth to get the star trails of the night sky, yeah.
Mm-hmm.
Doesn't the sun supposed to come up and do full exposure and gets rid of the sun anyway because of the sun's light? Because you get like 12 suns apparently as it rotates around Earth.
How long was the star trail taken? The star trail photo taken over from me?
Well, it would have to do one rotation. Would it to get one full circle?
No, it doesn't get a full circle.
Are you getting a
full circle? Therefore, it's not a complete rotation. What is shown is
okay. The ISS is bullshit. Space agencies are bullshit. If y'all, dude, here's the deal. You can think I'm a crazy flat earther. That's cool, but you do not, bro. None of you in here have to do mental gymnastics to defend a story they told the American public in the fucking 60s, dude. Y'all do not have to do that, dude. Think for yourself. Think for yourself. Please think for yourself.
I'm not point out to you that if you think that believing that all space flights, every single one, because it has to be for your idea to be true, every space flight, every satellite TV, TV satellite, every telecommunications satellite, every manned space flight, every unmanned space flight, every single one of them for 60 years has been faked. If you think that is a reasonable belief that any reasonable adult is ever going to take on, you are really delusional.
Okay, satellite dishes don't use satellites. And anyway,
complete madness.
Yeah, satellite dishes. Who is beating on a keyboard? It's 2020. Use a computer.
Oh, sorry. They're trying to find an excuse to fix this bullshit. This star trail bullshit.
He's knocking us for believing.
Kingo just posted evidence disproving that.
He's pointing out to him how absurd his idea is.
Okay, well, here's the deal, dude.
Where's the all of it, every single one was fake. Nobody ever talked about it.
No,
nobody
actually,
ever said, I faked a satellite.
Well, here's the deal, though, because the people
right now we've got GPS satellites that we all use every day, but they're all just fake. And it's
calm down.
And nobody knows about this but the flat earthers.
Well, here's the deal: the people that actually work on the satellites and stuff, like, they're not in on some big conspiracy or something. I mean, no one thinks that that's logical at all. They work on their parts, compartmentalized, and then the validation of the altitude and orbital The validation of the altitude and the orbital trajectory is what's being challenged. So no, there are in fact things up in the sky. There's no doubt. I mean, declassified satellites up there for years and years. We've actually seen some things that look just like satellites that are attached balloons crash from the sky. Now, does that say that they're all that? No, it does not prove that they're all balloons.
It just says there are stuff that we stick on high altitude balloons. Nobody.
Right. They look just like satellites. But anyway, yeah, that's what I'm conceding. That doesn't prove. Dude, I already said that. It doesn't prove that they're all balloons. But what I'm saying is what's actually being challenged specifically with satellites. It's not what you said, which was a straw man, that every single person that's ever had anything to do with the satellites in on this big conspiracy to lie about the Earth, and only flat Earthers have figured it out. No, all those people are compartmentalized, right? So it's the altitude and the orbital trajectory being challenged.
All right, stop talking. None of them have noticed, but you guys have. There would have to be massive teams of people somewhere to generate all this fake data that's going to fool all these people whose careers are based on this, but they just don't know about it. And the other problem that you have with this compartmentalization idea is that what you're proposing is that only a handful of people at the top know about the hoax, which means all the people underneath them, the people who actually build spacecraft, are going to go ahead and make us address the engineering challenges required to make a working spacecraft that will overcome the challenges that are required to put an object into orbit.
Yeah, they're given a task.
So the result of that will be you will have a working spacecraft.
They give them a task.
Dude, the claim, Gem, is that it's a fool's errand that they're given because it's impossible to put a spacecraft in orbit and get past the dome.
Well, again,
they go on this fool's errand that no one ever figures out that they're on a fool's errand.
Right. No, that's not what I said. They just assume that once it gets up there successfully, that it's actually the distance and orbital trajectory they claim, presupposing the Earth's a ball. They're giving it. I know people that used to work at NASA. I don't care about you trying to straw man my arguments. It'd be cool if you actually argue what I'm arguing like an adult.
Used to work at NASA, claim the Earth was flat.
Yeah, I know a guy that worked at NASA that says the Earth is flat.
Names, please.
I don't remember his name, but I can't get it out.
Oh, how convenient.
He's open and out about it.
But as Jem said, ultimately though, some team has to produce the fake telemetry data that makes
that's
the
not a
spacecraft
lie.
appear. Hold on. Like Jem said, though, some team out there has to create all the fake live telemetry data that's being fed to the team of people that are fooled into the fool's errand and make them think that they're actually launching a craft into space and that it's in orbit and that it's...
It's the algorithm, the algorithmic interpret. Yeah, do y'all have to just keep fucking interrupting? The algorithmic interpretation. Oh my God, the algorithmic interpretation is what they deal with. They deal with the figures input and then the way it deduces it, and then they go from there with the specific tasks that they're given. And we all know that's what they do. Now, of course, the algorithm assumes a spherical Earth in orbital trajectory in which you're going to maintain basically free falling around that object. That's calculated into its tracking.
So you would need a team of people to set all this up in all of these places around the world where satellites are monitored or people think they're monitoring satellites. You would need people to go in there and insert some sort of fake software that generates this algorithm on demand just whenever, I don't know, I guess whenever anyone tries to do a calculation somehow. I mean, what happens if they do one on paper? And then
what are you talking? No, they didn't have to sneak in to do anything, dude. Everyone thinks the Earth's a ball.
How does when these people are looking at the data, which tells them where their satellite is and what its power output is, and all those sort of things?
Yeah, this requires specificity. So, which one exactly you want to talk about?
So how are they? Where is that data that they are looking at coming from?
It depends on exactly what you're talking about. So if you're talking about the altitude, they're using radio waves. It's the interpretation of the duration of the wave to return back.
I can talk about some data.
Or to hit the satellite itself.
A guy called Astronomy Live. Okay,
sorry, go ahead.
Is it coming from a satellite? Where is it coming from? How are they getting the data on their computer?
Well, I'm not claiming that it's not there. I'm claiming it isn't at the altitude or trajectory that you say that it is.
Right.
So if it wasn't, I wouldn't be able to point my antenna at it.
Somebody must
actually. It would be at the right. It would be at a similar trajectory, right? But the interpretation of the trajectory is.
If it's not that, it would be somebody has to generate it somewhere, doesn't it? You're saying it's not coming from a satellite. Where does it come from?
I didn't say that, though. I'm saying if you send a wave at the satellite, I'm not saying it doesn't hit the satellite. I'm saying it's the way you interpret the data.
You're saying the satellites are all just on balloons, then?
Well, one thing we do know, some of them are. So what I do know is that they also have there's already commercially available self-sustainable high altitude drones that you never have to let come down at all. So that's commercially available.
So satellite TV that we had in the 80s.
They don't use satellites for satellite TV. So please stop saying that.
So where's that coming from then?
Towers.
Towers. So they're getting it from towers.
Yeah, go to dish.com and read how they get their service.
So
Hang on a minute. Hang on a minute.
So the people who are monitoring the TV satellites, where's that data coming from?
The people that are getting high altitude readings, that's coming from something that has a high altitude. We're questioning exactly what that is. You're pretending and straw manning that I'm saying they're not up there, and that isn't my argument.
But wait,
You're saying they're
hold on a
not
second.
where they're
Hold on a
supposed to be.
second, guys. Hold on a second. So a very typical example, Witsit, is there are these radar arrays all around the world, and what they do is they track the positions of all the satellites and update all the orbital elements of the satellites as they change. And then there's teams responsible for those satellites who will watch those orbital elements and do station keeping, right? Where they'll say, okay, we have to do a burn now to correct the orbital trajectory of the satellite, right? So those teams are getting fed data from a third party, the people that run these radar arrays, and then they perform maneuvers on the spacecraft, and then they get data back from these radar arrays that tell them how the orbital elements of the satellite have changed. So all of this has to be faked, right?
No.
Because it's all a hoax. What? No?
Nope, because whenever you're going to update your orbital trajectory with spherical assumption, have you seen how that maps out over a flat projection? Have you looked at the ISS trajectory, for example? So they think that they're doing one thing, but they're in fact doing something different.
A good example. The satellite, like the ISS, disappears across South Africa, and then a few minutes later shows up in northern Russia. How does that work on the flat Earth?
Teleport.
Okay, now I'm back. I'm uploading this image, and how does it work? I'm trying to show you. So this is how the ISS it should upload right now. This is how the ISS moves over.
Satellite.
This is how the ISS moves over top of the flat projection, and so you can see if you maintain. Yeah, exactly. So if you maintain that trajectory, that's all you're gonna do. Wait, time out.
Changing directions.
This is the trajectory, and so what they do is they make sure they maintain this trajectory. That's what they're doing.
You said over a flat projection.
Well, they aren't doing that.
Why did you say projection? Why did you say projection?
Because you've projected out the terra firma flat.
Right. No, I'm cool with that. But how well, you had to project it because it's not flat. Hey, is there any way I can?
Yeah, that's not why. You can't have anything 2D that isn't projected.
Hey, is there any way I can talk for a second?
Rubbish.
How is it changing directions constantly? I mean, it's going 17,000 miles an hour.
No, it's not.
It's verifiable.
No, it's not. So how do you verify it? How do you verify that it's going 5 miles a second? Please enlighten me.
Two observers.
Two observers.
One
What?
in New York, one in Florida.
This is funny. Y'all think y'all got me right here.
Okay.
Parallax, my friend, parallax.
No, please enlighten me how you No, the question is, please substantiate your claim that it's going 17,500 miles per hour.
Two observers. What's wrong with that?
Two observers what?
Parallax against the moon, for example.
Okay, so what about, how do you need to know the altitude?
No, not if it's over their head.
Okay, you don't need to know the altitude to know the speed. Okay, cool.
If it's directly over their path, if it's directly over their head, why would it matter? If it goes
Why would it matter?
It
It wouldn't have to travel as much distance if it's closer.
So if an airplane goes directly over my head, 10 feet above the ground, or it's at 30,000 feet above my head, and then it goes over someone's head in Las Vegas, and it's 10 feet above their head versus 30,000 feet above their head, there's going to be a difference in the speed?
As you get higher, you got to travel further.
Yeah, 200 more miles.
Oh my God!
You guys forgot the angle. Did you guys forget the angle?
He said overhead. The angle's
right.
As you travel, if you're higher, you travel further.
Real quick,
How much further?
Real quick
point.
Johnny, I don't think you're going to help here somehow.
Well, no, Jim, they've been telling about having the angle different between over your head, where your you're looking, and then where the object is with the other observer.
Yeah, we're talking about
That's not
validating the
doing
claim
it,
of
Sam.
17,500 miles per
that's
hour.
exactly what I'm talking about.
And it's
We're not triangulating, Zanuck. It's two people watching it go overhead.
But you got to use triangulation to get that.
No, you don't.
No, not overhead.
You just time how long it takes to get from one person's head to the other person's.
So you need to know the altitude.
No.
Yes, you do. Doesn't matter if y'all want to say
I
no.
hear what you're saying. You don't need the altitude. Why do you need the altitude when it's right above your head?
Because if it's higher, it goes further.
Yes, of
so to
course.
cover the same distance, to
It
cover the same distance,
doesn't
distance perceptibly, to perceive it covered the same distance, it'd have to go faster.
But you think the Earth is flat?
Yeah,
It's the same distance on a flat Earth.
No, it's not. The ISS is not the ISS is not 252 miles away.
Why not?
It doesn't matter.
How is it a different distance on a flat Earth?
It's closer. It has a circuit over the flat Earth. It doesn't go as fast.
How does it parallel the surface of the Earth? If it's a flat Earth, the distance between
1 hour.
Wait, if it's over your head.
If it's a flat Earth, the distance between New York and Florida is the same at 1 mile or 100 miles.
No, here's the deal, dude. I don't know exactly what the ISS
I don't care what it is. We're talking about how fast it's going.
Look, this is y'all just don't want to hear my actual point. I don't claim to know exactly what the ISS is. Is it actually something in the sky that's stop fucking
Don't
interrupting
bring
me,
up other
dude.
topics then.
Is it something in the sky? I'm talking about the ISS, you clown.
Stay on topic.
Okay.
You said the height. We're talking about the height above.
Oh, there you go. Interrupt me again like a fucking bitch. There you go. Okay.
You're talking about the height above
there
the
you go.
surface and how far it travels. On a flat Earth, as the previous speaker just said, it's the same distance in the sky as it is on the ground on a flat Earth, and then you change the subject because you got caught out.
No.
Pretty bullshit. We'll address that point then. Address that point then.
Well, I would love to if you'd shut the fuck up.
Okay, let his answer out, please.
Okay, so for one, I don't claim to know exactly what the ISS is, as in, is it something that's just in the sky that isn't man-made or something? Oh my god!
The question of geometry.
Just let him get his whole answer out, please, and then address it, please. Go ahead, Witzer.
Okay, so I don't know exactly what it is, man-made, etc. But we do know, of course, logically, that if something is further away from the surface to cover the same distance over the surface, it has to go faster, proportionate to the distance that is increasing away from the surface.
On a sphere, not a flat surface.
Right, on a sphere. Okay,
But we're talking about your belief of a flat Earth. We're not talking about sphere.
So do you agree that on the flat surface, the ISS could be much more local and not traveling as fast?
Well, we're only talking about the speed right now.
Okay. Do you agree that on a flat Earth, it can be much more local and not traveling as fast?
No, I don't, because if it goes directly over my head in one part of the country, and it takes X amount of time, and then goes directly overhead at another person, over another person in another part of the country, then the speed it has to go to travel that distance is the same to go directly over both of our heads, regardless of if it's a mile high, 100 miles high, or 1,000 miles high.
Or a million.
What if there's more than one? What if there's more than one?
We know a minimum. We
can have an arbitrary number of people between our two observers, or we can have our two observers situated so that they can see the thing at the same time, and it goes over directly overhead at different times. Doesn't matter how you set up the.
There's more than one.
It's at least a minimum distance, at least a minimum speed.
What if there's more
It's
than
a minimum speed, at least, right?
If there's more than one, we'd see more than one. You more.
This is what
Actually,
I said.
that's not true.
It's a minimum.
This is what I said. You can set it up so that they can see the thing at the same time.
Can you follow it
You
the
can
entire
set 'em
time,
up.
never losing view of it to make
Yeah,
sure it's the same?
Yes, that's what I just suggested.
So can you provide it, please, in the
You can
chat
have-
box? Just stop talking
can
and provide it. You're lying, so provide it.
No, you got
Where you can see the ISS in frame the entire time it travels.
The way to sort of
well,
galvanize
yeah.
is to ask the flat earther if he's got any evidence of more
So-
than
As I
one
said,
ISS.
you can
ever
do this.
being.
We've done this
I don't
in
need
this
evidence. You're making claims that you know what it's doing at 252 miles away.
We've done this.
Going 5 miles a second. So that's your claim, my friend, and I'm
We've
saying
done
you
this in
cannot
the
substantiate
show
that.
before. We've had several
You
people
cannot
on the eastern
substantiate.
coast of the United States
Your claim
watch
is
the
there's more than
ISS
one.
at the same time.
Miles, just let Slacker get in on this one for a bit, will you?
I'm not claiming,
Sorry,
by the
mate.
way, to clarify, I'm not claiming there's more than one. I'm just saying, what if there was? I'm not. That's
Well,
not my claim.
Then in this situation where we've set it up so that multiple people can watch it at the same time at different parts of the world, you would see those multiple ISSs.
You can't see something from 252 miles away the size of a football field, dude.
Dude, people can see the ISS 2,000 miles apart at the same time.
Yeah, so it's some light in the sky that moves.
And when you zoom in on it, it has a particular shape.
Oh, and so it's the size of the football field, and you can see it from 252 miles away.
You can see things arbitrarily far away.
Can you see a Boeing set?
contrast.
Can you see a Boeing from 250 miles
With
away?
a telescope, you can see a line of sight, and there's enough contrast. Yes,
You can't see a Boeing aircraft from
You can see
250
the
miles
landing
away.
light 200 miles away. Yes.
What about the
Like I
inverse
said,
square law?
What about it?
That's why I
You
said
can
if
see a
there's enough
candle.
contrast.
You
wouldn't
can
see
see a
shit.
candle at 30 miles. You can see the filament of a light bulb
You
from
can
30
see
miles.
landing lights of airplanes at 250 miles. This we know.
Oh, you can see airplanes at 250 miles?
Yes.
The lights.
Wait,
you
what
can.
airplanes go 250 miles?
The lights. Yes.
Away from you is what you're saying? That's not the
Yes, you're
same.
Yes, you can.
It's not quite the same, right?
You're right, because the air's thinner above your head. If you're looking 200 miles across the ground, that makes it even harder.
Sure. It would change more, yeah.
So it should be easier to see something illuminated by the sun when it's night.
Well, if
for
someone
you
wants to show
at
me
200 miles
someone
above your
seeing a
head.
plane from
Wait, can
52
stop
miles
here?
away, that'd be cool.
With the speed?
The light's only a couple inches
We're
in
getting off
diameter.
topic again. We're getting
We've discussed it.
Yeah.
Speed. And the speed is verifiable. 3 observers going up from New York to Florida, and you can have 3 observers up the coast in the path of the ISS. You can get your flat-tard friends and see if you all can witness and clock it. Doesn't matter how high.
All right. How about this, guys? This is gonna make this is gonna make y'all spiral, I know, but what if there's something in the sky? Sorry.
Sorry, Witsit. Moyak, you're very
Yeah,
difficult
we
to
can't hear you,
Go
Moyak.
ahead.
You're in a toilet.
Go ahead, Witsit. Sorry.
This is gonna probably, I'm sure y'all are not gonna like this, but what if there's something in the sky and it has the circuit, right? It moves up in the sky, and then we have a tracker for the ISS, a little app. We go out there when it tells you that you can see it. They have something up in the sky that you can see.
Well, that's kind of exactly what it is. It's called the ISS, and it's in a
Well,
circuit
no,
called
but
orbit
you're
around
not.
the Earth.
Y'all didn't listen. Y'all didn't listen.
What if the thing that the app told us were real and we got to see it?
Well, the problem with it is that you shouldn't see it from 250 miles away going 17,500 miles per hour
Why
or
not?
5 miles a second because
not?
there's no evidence it's actually going that fast.
Well,
or
we just
anything.
went over how you could verify it's going.
No, we
Did
actually,
you
y'all ran away from
forget?
that.
Well, you ran away by just suggesting that there's more of them when multiple people can watch it at the
that's
same
not.
time and verify that
That's
there's
just a
only one of them.
random. Well, you only see one at a time. Yeah, of course.
We see the
No
same
way.
one at the same time.
Okay, and it's supposedly the size of a Boeing, 252 miles away.
Okay.
And you can see them from thousands of miles apart on the Earth. And you think that's real? You think that's real?
We can say thousands of miles even.
Oh
Yeah,
my gosh.
not quite
Yeah,
thousands,
you think you
maybe
can see
1,000.
a Boeing from 252 miles away from thousands of miles apart on the Earth? That's what y'all
With enough contrast, yes.
Yeah.
And
it's a
I'm
bit
crazy.
bigger
You can
than
easily
that.
see it from 1,000. Yeah.
1,000? When was the ISS at 1,000
Not
miles?
1,000 miles in
What?
altitude, 1,000 miles
last
away from
Saturday?
the observer.
Wait, you said
it was there 1,000 miles from me last Saturday. Watched it go right across the sky. Have you ever
I'm
looked?
talking about its
It's
altitude.
not. Well, you got to remember there's multiple things involved. When
Well,
it's
that's not what I'm
maybe
talking
200 miles in altitude. Well, listen for a moment. When it's at that altitude, but at near your horizon, it's nearly 1,000 miles away, or
We're
somewhere around
talking
1,000.
about the
depends on
altitude
topology.
claim.
I thought we were talking about distance.
We're talking about the
Be
speed
consistent.
also.
The reason they had to
That's
say it
the-
goes this fast is because it's supposedly 250 miles projected over a globe.
Well, that's it.
More so.
Its altitude is. Well, wait a minute. Its altitude is insignificant.
No, it's literally not.
No, well, I mean it's significant in allowing you to see it further away. Yes.
Could it be? Hey, could it be?
Let me finish for a moment because let me finish for a moment. You're going on this. If it's smaller, it doesn't have to go as far, so it can go slower. Well, you got to remember that, assuming we're correct, that the Earth is a globe, it's going around the whole radius of the Earth plus 200 miles.
The Earth is.
That plus 200 miles is insignificant compared to the radius of the Earth.
But yeah, you're reifying your radius.
No, it's the minimum
value. Attention, so.
I admitted, assuming we're right.
Assuming you're right, a bunch of shit. Bendy space.
That's what we're talking about. You're talking about.
Assuming you're right, everything came from nothing and I came from rocks.
I'm not talking about that right now. I'm talking about the shape of the Earth.
Yeah, I don't want to assume you're. I don't want to just assume you're right. So.
Well, you were assuming that we were right when you talked about if it were closer, it wouldn't have to go as far.
I just entertain you. I just don't want to keep doing it.
Entertaining the same thing. So let's be consistent.
You're entertaining your belief. You're not stepping outside of it. I'm the only one in this room. I'm the only one in this room that is willing to even step outside of some predisposition in this conversation, and we all know.
I did that just a minute ago when we were talking about observing it over a flat Earth.
Okay, can the sun be? Could the ISS be smaller and closer?
Sure, yeah. Hold up.
Well, you would see similar things if you didn't look too closely. If it were closer and smaller,
well, you could make it to where it looks exactly the same, right?
You would, if you paid enough attention, you would notice differences.
No,
but
so you're saying you couldn't maintain the perception looking exactly the same if it was smaller?
It would be on fire.
It would change.
Let's ignore the on fire part for a minute. If it were closer and smaller, and you paid enough attention, you would notice differences. But to a naive observer, it would look very similar.
But there is actually a sweet spot you can maintain, or you could accomplish that would look exactly the same.
Yeah, the same spot.
No. You can make the angular size the same. You can make the angular size the same by decreasing the size of the object and bringing it closer.
Yes, but it would burn up. Don't you understand?
The problem is that
ignore the burning up for now. There's other things besides angular size that we observe when we look at this thing close enough. We observe the change in angular size as it comes from the horizon towards overhead. We observe the change in angular velocity as it goes overhead, and we observe the distance that it's visible away from us between two different
observers. Say the object's 1/5 the distance that you say it is, okay?
Then it wouldn't be as visible between two different observers for the same distance.
Exactly. Even on a flat Earth. Even on the flat Earth.
The time for one orbit is directly related to the elevation above the ground.
Where would you know? Where
closer?
Well, we're assuming
it was
magic,
closer,
so that's kind of not
less than 92 minutes to orbit.
Okay, so
at 92 minutes, that's a very specific
if it were
distance.
at 50 miles instead of 250 miles, right? So where would it cut off on a flat Earth where I could no longer see it? What distance
would be
would
closer.
you be able to see it?
I'm not going to sit here and do all the geometry to figure it out, but it would be closer.
Well, that just, how much closer?
You can guess it
A lot.
yourself.
A lot closer.
If you want to figure it out, you can do the geometry yourself.
But the problem is, on the flat Earth, it wouldn't move across the horizon the way that we observe it. The angular change would be much, much smaller.
No, the angular.
As it got further away, there'd be very small changes in the. I'm sorry, I meant the angle of elevation, the angular angle of elevation. As it got further away, it would hardly change for a long period of time.
If it was closer?
No, if it's just on a flat Earth, it doesn't matter how high up
closer.
It is. Sure, we can say that it's closer, but still, what would happen
would change
is
then a lot.
When it's overhead, it would change positions a lot. But as it got closer to the horizon, it would hardly change at all.
At 1/5 altitude.
Yeah, at 50 miles up, let's say, or 30, or 30 miles up, or 20 miles up. Of course, you could do the math.
Yeah. Okay. So here's the deal: you can't see things forever.
All you have to do is take the tangent of a triangle. Yeah, just take the tangent of a triangle and work out the angle.
Yeah.
Also, just did the quick math. If you made it 50 miles up instead of 250 miles up, it would still be traveling greater than 16,000 miles an hour.
No, the Earth isn't a ball, dude. I think you're missing that part. You're missing the part that the Earth isn't a ball, dude.
That's why you use the minimum value. We know at least it's going 16 to 17,000 miles. We know this.
Y'all just stick your chest out with that R value, like it's not presupposed.
If it's a circular path, we know it's going faster.
I'm going by the size of the circuit that it would have to make on both models.
Oh yeah.
It's pigeon tested, and then it's pigeon test out the R value.
So it's exactly the same on both models.
Hello, how you doing? Can you tell me about the giants that roamed the earth?
Yeah, I think there might used to be giants. I don't care if you think that's crazy.
When were there giants?
I don't know. There used to be big bones found, and the Vatican came in and told us they were dinosaurs.
How big are they? I mean, how big were they? Like 100 feet?
There were some pretty big bones. Oh, how tall were the giants? I don't know.
Big bones.
No,
Who made
every ancient civilization claim? Every ancient civilization claimed there used to be giants, and we were told they're all stupid primitive people.
There's some people who claim that they were like miles tall, and
most of them. Well, I don't know how tall they were, man.
Right,
actually, if you look at all the information, it looks like they got smaller. I would say that they were really big. I don't know. I don't make claims to miles. That sounds crazy, but they got smaller over time.
Right, so were they miles or feet?
Okay, I'm not gonna sit here. I'm not like y'all's punching bag. I get it. You're a closed mind.
Can I ask you one?
I'm genuinely interested in this.
Can I ask one question?
Go ahead, man.
All right. Let's say you were successful in whatever you're trying to do here, and you convinced us all that the Earth was flat. And somehow this recording went viral and convinced the entire country and maybe even the world Earth was flat. How would you feel tomorrow?
I would just be happy everyone gets to make their own decision instead of having it made for them. I'd feel good.
Hello. Thank you.
I have a question. Can you guys hear me?
Yes.
Yeah. Hello, a bit new here. I just had a question as well. Like, I've been following the flat Earth thing for a while, just kind of lurking on the different channels and stuff. And the thing that always struck me was that, you know, all the modern advancements that Witsit and all the flat-tards get to, you know, computers and fucking air travel and everything else is built around our knowledge of physics and mathematics, right? So what I want to know is when the flat Earth truth is revealed, what advancements for mankind is that going to open up that we currently don't enjoy?
An absolute ton. So none of those advancements you're talking about require the Earth to be a ball. I'm not sure if you knew that. None of them. Literally none of them. Literally none of them. But we would be able to
enjoy. Kango, just let him get it out, and then
literally none of the technology at all has anything to do with the Earth being a ball.
Wrong.
But it actually would help us out a ton because we would be able to better understand phenomena, right? Because if the Earth's geocentric and we have an electromagnetic field, and if the Earth is stationary, and so we see some deviation or precession in certain instruments, we would know there appears to be some background drift. We'd be able to better understand things that we presuppose emptiness and void of any material being there. The way that we observe the entire world and interpret it, science as a whole would progress exponentially.
Can I ask a follow-up?
Also rather long. Let Kango follow it up if you don't mind, guys. Go ahead.
So computing, satellite communication, air travel, scientific experiments like LIGO and figuring out the fact that, you know, space-time exists and all these things, that'll get more accurate, will it?
Space-time doesn't exist. They didn't use a scientific experiment to prove such either. So please stop fossil using the word scientific experiment.
They did. They didn't. This is a crazy thing. And I shouldn't have joined this, actually.
Yeah, probably not.
Listen, you think all the body of science, all the people in the world are all working towards something that they've all been deluded, to be honest with you. And you're sitting there saying like, oh, space-time's true, but it's not actually true. Do you know what I mean? It's a concept, mate. It's not actually proven. That's just.
I guess the other thing. I mean,
are there 3 dimensions?
Dude, space-time is a conceptual abstraction. Okay, it's a combination of 2 concepts.
Have you guys ever worked?
What was the women ever?
Have you guys ever? Yeah. Okay. So here's the deal. Michael said Marley.
Have you ever worked in labs? Have you ever worked with people that have done this kind of work?
What kind of work?
Well, like involved in
I was in school. I went to a college preparatory school. I was in physics 1 and 2 honors, chemistry 1 and 2 honors. So I've been in some labs. Well, what's the point?
Well, it just strikes me as strange that, like, the denialism. I just don't know how you. I don't know how you operate with. Like,
I'm not denying it, my friend. It sucks. I'll be honest. It sucks. It sucks.
Right.
Okay. I'll be honest.
Look, you've got stuff out there. They're telling you, right, that you're supposed to see like 66-foot drop in over 10 miles and of curvature. Everywhere I've gone, I've never experienced any curvature in my entire life.
Brommy,
do you know what I mean? And they're telling you it's not.
See the curvature, you know, because they're so
I never wanted interruption. I wanted to finish off what I was saying, to be honest.
I know,
what do you want, Chris?
You've went a lot, and I've not, so fuck it.
What do you want?
I want to talk about the Giants.
Oh, the Giants look amazing. Basically,
not from you.
Yeah, I've not seen any curvature, mate, and they tell you that you should see it, and you don't see it, but they tell you don't want to tell you don't see it. They go, oh, because of reasons. Don't talk over me, man, you piece of shit.
That's all you've been doing.
Just shut up, man. I haven't spoken for like the last half an hour.
Okay, well,
thank you.
It's because you're muted, Brummy.
Kango, I've got a quick question for Kango, actually. This is going to sound a bit weird, but you didn't ask these questions on a radio station recently, did you? Or similar?
I didn't, no.
Okay, no problem. You just sounded like someone who did. That's all.
All right, mate. Well, I just want to say to you, you go to school, you know what I mean? And then they tell you the world's a globe because a ship's going over the horizon. You test these things, you look into them, and you realise there's inconsistencies in what they're telling you. You don't see what curvature that they say you're going to see, and their explanations fall apart, and there is alternative explanations.
I mean,
and people don't like to hear it because they just interrupt you every time you talk.
You could put a weather balloon up for about $300 with a regular camera, not a fisheye camera. You could, if you're in the UK,
don't patronise me by saying like I'm stupid. Like I'm going to go. So I've seen the high altitude.
No, you can do it. You don't have to
no
look
curvature.
At it. You can do it. You can go online and just buy.
I've seen it, bro. I've seen the footage. There's no curvature, bro. There's none.
Really? You think that's an honest assessment of those videos to just say there's no curvature?
Brummy,
even though
I'm not stupid to go fisheye lens.
All of those videos where you see it is some sort of a fisheye lens, and you'll see a straight horizon, a concave horizon, and a convex horizon. That you can conclude. You can just your honest assessment of them that it's all just flat.
What my problem is, this guy thinks we're stupid. Flat earthers aren't dumb, mate. They're very intelligent, sophisticated. I can hear it in your voice. I can tell you think we're stupid. I can tell by the way you're talking.
Telling you ways that you could prove.
No, I can tell by the way his tone of voice and the things he was saying. Like
he took a physics class. He said he had some upper education in math and science, yet he doesn't seem to understand trigonometry or high school, college preparatory, high school. Right?
Who gives a fuck, dude? I went to college, I had a full ride, dude. I just never went to class, and I don't care about any of that shit. So it's not that I don't understand trigonometry. You just don't like my response because what I said is to equate that to physical evidence of, say, altitude or something. It inherently requires actual location.
No, it does not. Equatorial mount is a geometry example of why everyone seems to deny that.
Can I ask a question to follow up with Kango?
Go ahead.
This is something I asked a few hours ago to Don, and why does the Navy understand that when objects disappear or seem to disappear over the horizon, it's the curve? You'd think the Navy would be very interested in, accurately following targets and figuring out what's going on over the horizon. So what is the Navy doing with it?
Part of the conspiracy.
And not just the U.S. Navy. This is an ancient thing they've been doing for centuries. So what are they getting wrong?
What are you talking about?
Are you talking to me?
No, to Witsit.
Okay,
I don't care what you have to say. You're not real.
Well, I don't really care. It's the same thing anyway. Perspective, like the horizon, the cutoff point is the same as curvature. It's an illusion.
Okay, so what exactly are you talking about? The Navy. You would like to say something?
200 feet of boat missing after 20 miles. Is that some kind of compression? Or is that actually
too bad that doesn't happen the next day, huh?
It does. Actually.
No, it doesn't. You're a liar. You're a liar.
Well, sailors are very familiar.
Then just cite it. Then just cite it, my friend.
Well,
I would love to see it. I'm not biased.
Put a pencil in a glass of water.
My question.
Is the pencil gone, or is it just the apparent position?
You think that's that's water?
Magically not there anymore.
It's the water.
I think
that's not air.
Right.
You're talking about refraction, though. You're saying it's a
water and air are different, dude.
So Witsit, answer my question, please. Why does the Navy have this all wrong?
I just said specify your claim.
No, you know what my claim is. That when objects...
Your claim is vague as shit, dude. The Navy knows the Earth is curving.
You know what I mean.
Cite it exactly with specificity so I can respond.
You understand me. I've just said it. You understand me.
Okay, when a ship is in the distance and it goes over the or past the horizon and it disappears bottom up, why doesn't the Navy develop some alternate explanation as to... it's not the curve. It's some, magical perspective illusion that you're describing.
What practical use requires...
Why don't they claim what you claim?
Yeah. What practical use requires that they assume the Earth to be curving?
Oh, everything. Targeting.
Name one.
Navigation.
Navigation lie. Name another one.
Targeting missiles.
Targeting ballistics.
Long distance ballistic trajectories. Assume a flat, non-rotating surface that's been declassified.
No, it hasn't. No.
Okay, provide proof of the opposite.
Hundreds of years of navigation.
You provide the proof.
Okay, I will. Ballistic.
Of years of
now you're conflating from the
sailors.
Navy to hundreds of years. You need to calm down. Yeah, that's what you need to do. So if you want to try to have an adult conversation, if you want to have an adult conversation where we have like one topic at a time that we're discussing with specificity, I'm happy to do that.
One question, and
you've asked like 15. I didn't deflect anything.
Yes, you
I asked for specificity.
And I think that was fair, McRuben, because you did say the Navy, and then it ended. And I thought you were going to say, well, we've got this, long-range firing table that accounts for curvature of the Earth or something, and you didn't. You just said, well, ships go over the horizon, but I don't think you can, unless you can specifically link that to the Navy. Specifically, rather than just say, well, I say it's required.
Well, because
he's just going to say, I think it's not required, and they can do this on a flat.
Well, because when the Navy is, or when sailors are trying to track a target, for instance, and they see it go over the horizon, they need to know the exact position of that target. And by putting flat Earth magic into it, they're not going to compute that position.
So is your claim that for target acquirements on the water, they have to factor in Earth curvature?
Oh, definitely. If it's
provide evidence, because there's evidence directly contrary to that. So can you provide it, please?
Find something saying that we assume a flat, non-rotating Earth in some of your NASA documents doesn't mean you understand what they're actually
straw man. So if you would like to provide evidence,
you brought it up. I didn't bring it up.
If you would like to provide evidence that they actually account for Earth curvature for target acquirements,
every one of them has problems. And they assume those two things to make the simplicity of the problem more direct.
Would you like to provide any evidence of them accounting for Earth curvature for target requirements?
I can show you a firing table that does account for curvature.
Why do ship navigators not flat earthers?
There are flat earthers within every sector.
Ship navigators specifically.
Navigators, people that aren't dumb and think that you can't navigate only on a globe. No, that's not proof either way of shit.
What about a sextant that used to be used for oldie-timey nautical navigation? That only works on a spherical.
How's that?
Oh, it's because it's the geometry. It's the fact that you line up with a star with an angle on the sextant, and that actually only works if it's spherical. I mean,
you're just saying.
I was going to ask you actually in another debate.
From the military artillery manual, I have it posted. I have it posted for you. The military and their adjustments for curvature and rotation.
Okay, and this is for long distance weaponry of target acquirement.
Correct.
Provide the document, please.
I just did.
No, you provided a screenshot. Provide the document.
I can provide a
document. You do not think that document is real? You think
no, I want to read the context of it because I know who you are.
You can look it up based off the numbers on the top right corner.
No, I said, is this required for weaponry of target acquirement?
Yes, for target acquisition.
Okay, and it's required for practical use of weapons.
Yes.
Please provide the document.
I'm nearly at one. I can get one.
Because you're now doubting the document as not being real for some reason.
Well, it's fair. No. If you're quoting a document, Zanik, just get Get in the bloody document. You don't have to go into this and you're doubting it's real. Of course,
I'm
you
not
are.
claiming it. I'm not claiming the document's fake.
If
I
he
just
posted
want
something, we would bloody well doubt.
I gave you the context. I'll find it.
Well spotted, Jem, because this is what happens. Like he might refuse it slightly, but you don't have to mischaracterize what he says and strawman and argue like something he didn't say specifically. This keeps happening over and over again. It's like it's getting tired. It's getting tiring to hear you guys do this. Just quote him properly, or bring the evidence to the table and we'll look at it.
Yeah, I would need the context of what you're talking about because, for example, I have a document, and I think I brought it in here one time, but it does say for ground weapon systems, they assume a flat non-rotating surface for target acquirement. A rail gun, although it does have a very high trajectory. I mean, I've never seen fully in-depth declassified documents on it, unfortunately, of course. But that's no good. But I'm just saying we need some evidence.
I've got one here, but hang on, nobody click on this yet because it did give me a bit of a funny. You're going to somewhere insecure. So go there at your own risk. I have gone there many times and not had a problem. So anyway, I'll tell you what it is. It is it's called FM640 /MCWP 3-16.4. Tactics, techniques, and procedures for field artillery manual cannon gunnery. And this is from Department of the Army, U.S. Marine Corps.
Okay. So,
and this has a firing table similar to the one that Zamet posted.
What are they firing exactly?
Let me see. So it says field artillery manual cannon gunnery. So it just says manual cannon so far.
Okay.
Anyway, I'll post what it is. Hang on, I'll just post that.
Yeah, I mean, I'll check it out.
Like I say, follow the link.
Yeah, they've got like a double R value thing in the formula. So the people that
you'll be able to find if you search for that thing that I've just posted.
No, look, they've got that formula there, squared R2 plus R, and then like a minus R at the end. So maybe they equate the R out. Let's have a look. How does this work?
Dude, I mean, Xanax sent a screenshot talking about rotation.
Here's another one. Here. Go ahead and click that one. It's got another Navy firing table in there.
Why are you even arguing this?
This dude just posted a screenshot of rotation. So I'm going to look at the document.
I think
I'll look at y'all's documents.
They've got the R value in the formula.
Because we have
that's not my point. My point is not even about presuming the R value. My point is for practical usability, for long distance target acquisition, if the Earth is curved, you would have to account for it. So I want to see how they do that because I've seen only information contrary to that.
No, you haven't.
Okay. Yeah, I just explained one. Horizontal propagation for ground weapon systems over a flat, non-rotating surface is assumed.
Yeah, that's the intro part of the manual. And it gets to, Coriolis and all that.
They simplify the setup. If you take those into account, it's much more complicated and not needed because the rounding error is short distances. That's why.
Well, it's not that simple. Unfortunately for you, mathematical simplicity is not a sufficient rebuttal because.
Hello, I'm still talking. They do the same thing in general aviation and in military aviation and in aeronautical engineering.
Yep.
They have certain things that they assume a flat and non-rotating.
Yeah, we get it. It's mathematical.
You're talking over me
because we've all heard it.
No, but you keep on denying it, and we keep on telling it to you.
No, I'm going to tell you why it's wrong. Okay?
Why is it wrong?
Okay, because you saying that it's assumed simply because of mathematical simplicity does not address my actual argument right now, which is practical usability.
Right.
So the practical use case,
That's why we give you the FT 105-402 to give you these. And I'm pulling up the manual right now. I'm trying to.
No, you screenshotted something about rotation. That's what you did.
All the same. You said the topic was rotating or flat. Flat and non-rotating.
That's not true. What? The topic was rotating or flat. What are you talking about?
You said flat and stationary, flat and not rotating surface. So I'm showing you.
What I'm saying is that the surface, if it were curving away, it'd have to be accounted
So we have a
for
flat-
target
so we have a flat
acquisition.
rotating surface. So you're saying that they say we have a flat rotating surface? That makes a lot of sense.
What
How
I'm
do you
trying to
know
tell
it's
you
fluid?
is,
A
yeah,
full
you're
ride
not. They
for
don't
what?
actually
You
account for
get
the.
full
They don't
ride
actually account for rotation
You get
though.
full
So
ride for
too bad.
academics or some sport?
You're now trying to project onto me
I'm
the
not.
fact that you were supposed to
You went to
provide
school. How
evidence
did you
that
like
they account for terra
How is
firma,
it possible you don't
curving, and
understand
you
this?
sent
I don't get it.
rotation.
I don't understand.
You sent
how you got
rotation,
that.
and you were
bring their
supposed to send terra firma. What?
With it, we've had artillery guys come on here and scan in their actual field manuals, which show that they account for rotation and account for curvature of the Earth before.
No, they've never done that in real life, though. Like, I mean, what use did they do that they accounted for Earth curvature?
You know, that's guys.
Well, they didn't do anything. I know many people in the military, my friend. I have quite a few, like, Marine friends.
Yeah, and
Here's one of the pages of that
copy on the
document.
base doesn't have to account for curvature.
Here's a copy of that page of one of those documents.
It says it only
What does
has,
that say there?
only has a 15-mile radius. Anyway, it says here on the ballistic gun. 15 miles. So that's only what 66-foot drop anyway. So it would be quite a like, you know. Then you would, you know. So I don't know. What else is saying?
Another screenshot talking about rotation of the Earth.
Huh? Oh well, I'm gonna take every. You know, you don't just dismiss evidence. We're doing
Wow, I'm just confused why someone else just sent another screenshot of rotation of the Earth. Do we agree there's a difference with rotation compensation and terra firma compensation?
And
I'll show you the table for that. It's on that same
Thank you.
document.
That's
It's
what
on a
we're
different
talking
page.
about. So, Jesus, dude.
Well, in the one I've got, it has. Oh, let's have a look. Table F.
Here's another page from that firing table about how much to add in the drop.
Oh, finally got
there.
to it. Yeah, the bullet drop
Here
or
it
the
is.
Earth curve drop.
Well, this one has
Earth
it. I
curve.
believe. It says it says range column 1. This is the distance measured from the muzzle to the target on the surface of a sphere, concentric with the Earth. When the range is used as the entry argument for this table, it is expressed to the nearest 10 meters. Interpolation is necessary. So that sounds like it, right? I think it does.
So what page is this screenshot from?
All right.
That Jake on the plane said?
Are you on it's from the manual on that first link that I posted. Here, I'll post it again.
But where's the? Well, just say the page.
It's bullshit.
So I think we would all agree, right? Like that, if a railgun shot 100 miles, for example, it would definitely have to account for the Earth curve, right? Like so. We agree with that, right?
I think in the case of the railgun, I think maybe that's a little bit different anyway. I mean, it does, yes, but I think usually that's going to be targeted from an aircraft. So, I mean, I'm not.
Well, not necessarily.
I think they're going to. Well, no, you're right, not necessarily, but I think usually it's going to be. If it's going to be used at long range, it's going to be used like that.
Well, I would
But
assume
think most
probably that would be
Yeah,
way more
but
efficient.
the ballistic firing table is still going to account for all that.
Well, no. Well, that's the thing, though. So you're saying that when they shoot the railgun, and we don't know the answer to this because it's not declassified, but I mean, it would have a drop, obviously. I mean, you're shooting 100 miles. I think it's supposed to go from Mach 7 to Mach 5. Right, of course, we all agree the bullet's going to drop inherently, but there would be an additional drop of Earth curve. We would agree that you would have to account for that to hit something 100 miles away, right?
Right.
Okay.
I'm just saying that I think in that case, I'm not sure if that's the actual method it uses, because I'm thinking if it's just following the line of a laser at some point.
It's not guided, Jim. It's not the railgun is not a guided projectile.
It's just a ballistic.
It's a ballistic projectile that just shoots really fast
and far.
I'll give you a hint. It kind of remember the discussion we had about the that rocket in the desert on the rails. They were 8,000 miles an hour. Remember that discussion? And
yes, I remember that we talked about the railgun. I had to pull it from you. That of course you'd have to account for the Earth dropping.
Not talking about a railgun right now.
Well, yeah, that's what he brought up when we were talking about the railgun last time.
Right. And so the centripetal force acting on it is the weight of that projectile. Would you not agree?
Well, the thing about what you're claiming is that the Earth is accounting for two different fluctuations: Earth curve and spin.
What did that just mean?
What I'm saying is, I don't agree with your claimed causation of drop or where the bullet lands.
So they measure.
I'm saying,
well, in that situation, they measure over 2 miles in the desert. There is a 8-inch drop over 1 mile, and a 32-inch drop over the 2 miles.
When they do what?
They have a track on a rocket-propelled canopy.
Okay, so the rocket loses nothing. It stays level.
It stays on the tracks, and the tracks naturally has a curve of 32 inches over 2 miles. Yet it's not being steered, and it's not creating any kind of forces on that track to try to lift off and go straight. Because it's obviously falling with its weight.
What if the elevation was going down a little bit?
No, on a flat, level surface.
A flat, level surface in a desert.
What? In the desert.
I think the bullets on them guns they probably have to, if they're going further distances, they shoot them higher anyway, so the bullet dips. They're like a sniper rifle. When you shoot far away, you shoot above the target, so the bullet dips down anyway.
Only it's like way more extreme, right? Because it's going 100 miles. So, but it goes Mach 7.
Right.
And then it hits at like Mach 5. So, I mean, it's...
the force vector...
7 or Mach 5 doesn't mean that it doesn't fly in a ballistic arc.
I just now said it does.
It also doesn't mean that the weight vector doesn't change along its path.
Doesn't mean it's curvature. That's not proof of curvature either.
Well, of course it has an arc, and it's going super, super fast. So the faster, of course, the less the arc. But they factored that in to land onto the target. But if where it's landing onto the target is additionally falling down and away from them because the terra firma of Earth is curving, you'd have to factor that in additional to the drop of the bullet. You'd have to make it land where it's supposed to, which would be down and away from you around the Earth.
And?
Well, that we would need, we would need proof. So you would agree, railgun cannot work on the ground with target acquisition if it doesn't factor in the Earth drop as well.
Not necessarily. If it's shooting at a stationary target where it has a known position, it just has to make the appropriate calculations.
The appropriate calculations would include the Earth curving.
You don't even have to paint the target.
The appropriate calculations would include the Earth curving.
Yeah.
That's the whole point. Okay, so it would have to, for it to work, the efficacy of railguns is dependent upon factoring in curvature.
And rotation.
Yeah.
And rotation. So all of a sudden now, all of a sudden now you get color. Hold on. All of a sudden, hold on, man. All of a sudden now you get Coriolis effect when they're shooting bullets. Not when you're flying planes.
Long range projectiles, yes.
Yeah. So I would have to go out on a limb here and say we'll probably never see that data, huh? We'll never actually get to see it because we would know definitively. It wouldn't work, and so its physical use would be physical evidence. So if it did work, you could prove that it only works because they factor in Coriolis and Earth curve.
I'd like to see an airplane travel at 1,000 miles an hour towards the sun above above the clouds and do sun chasing. Chase the sun and bring the sun back up, because if the Earth is causing the sun to rotate, if you're in an airplane,
Brian Cox did that. Was a well-known thing on the Concorde. That was a well-known thing on the Concorde.
Where have you been? You're late to the party.
Where's the footage?
Whatever. Concorde goes 60,000 feet.
Yeah. 60,000 feet and over 50,000 miles an hour.
Where's the footage? Where's the footage?
Was it Brian Cox that did that? I think it was.
Wait, did you say the Concorde goes 50,000 miles an hour?
No, excuse me, sorry. 1.6 thousand miles an hour. 15,000 miles. 1,500 miles an hour. Sorry.
Okay, yeah.
60,000
feet. Man, that's nothing.
15,000 miles an hour. But anyway, the point is, it can chase the sun down, and you can watch the sunset on takeoff, and then watch it again while you're in flight.
Yeah, because the sun's like local and
because why would you say something silly like that?
Have you ever actually thought about it though? Have you ever entertained it?
I have.
Oh, okay. Have you seen the high altitude footage where when we get up real high, the moon gets super, super, super small? Normally when we get those though, they don't have a really good filter. Like if you have the best solar filter that exists, then you'd be able to really compare. Because the moon, dude, it gets so tiny when you get high in the air. Have y'all seen that?
No.
Well, I've been in a plane and I've never seen the moon get smaller.
No. But this is high altitude footage.
It's called a wide angle lens, and that usually makes objects like that look very small.
I'm pretty sure like space agencies themselves have released this footage that I'm discussing.
No, but what you're discussing is nonsense because the object does not change angular size as you go up.
Oh, so the footage that came from NASA is bullshit. Gotcha.
I got into
where you're missing some very.
Hold on a second. I got into a debate with Nummy where he said there's never been a ISS spacewalk where you could see the moon in the frame. And so I dug through hours of footage and I found a shot where they were doing a spacewalk and the moon was behind the ISS. And we computed the angular diameter of the moon and it was exactly what it's supposed to be in the shot.
Yeah, what a shocker. Because they would be stupid enough to let that go underneath their nose.
You just said that the space agencies are the ones that showed this. You just said that 30 seconds ago.
That's what I'm saying.
I like the ad hoc. I like the ad hoc adjustments to his
everything you say is double speak. You walk everything back. You know that, Whitson, don't you?
That's called ad hoc. That's called ad hoc.
I don't want to hear irrational people tell me what's rational. Discord kicks me, but here's the deal. Look, we just discuss what the truth is, and y'all just don't like it, but it's whatever. I don't have to just blindly believe your fairy tales about space agencies. All I was letting you know, my friends, was there is footage out there where when you get really, really high in the sky, the moon looks tiny.
No, it doesn't.
Okay, so if I provide it, when I provide it, are you going to admit that you were wrong?
Take a picture of the moon with your cell phone.
Is that Brenda? It sounds like Brenda. She says she's going to admit it. Zanuck, are you going to admit you were wrong?
What you're going to show? Yes, I would admit if I was wrong, but I'm not going to be wrong.
Okay, anyone else want to take up a challenge?
What you're going to show me is something that does not show its angular size. You're going to see a picture and a little dot and say, see, I'm right.
Well, that's what I'm talking about.
You compare it to. You got to have something.
Oh, so what I'm saying is that when you go high up in the air, the moon appears to get smaller. Are you disputing it? Yes or no?
No, it doesn't.
Okay, I'm going to provide the evidence that it factually does.
Go ahead, provide your evidence.
Go ahead.
Evidence down. It's going to be that simple. That we know we can do.
And will there be a photograph that compares it to a lower altitude in this that's taken at the same angle, field of view in the camera?
My point is that this came from a space agency itself. I have to go find it. Iru showed it, and whenever they go high up in the air, the moon.
What you read.
Why the fuck do you have to talk over me?
The first time you didn't understand something you read, such as NASA's.
It has nothing to do with reading. So what are you talking about? You're just saying stupid shit, though.
You brought up NASA and their assumption that the Earth is a flat and has a non-rotating surface. You brought that up.
No, I didn't. You brought that up.
No, I didn't do it. You did.
You did. You brought up NASA, assuming that. Yeah, you conflated my position earlier.
So does every single.
I have a good memory, Zanuck. Sorry for you. I have a very good memory, and you actually brought that up, straw manning me, conflating that into it. I brought up specific documents
from NASA. Assuming I have the picture. I saved it, by the way. I'll post it for you.
Please do.
It says NASA on this one document that assumed a flat, non-rotating.
I have not posted anything like that today or discussed it at all. Only you had brought it up.
Ago.
Okay. What a weirdo.
I captured it and saved it for you.
Okay, cool. That's a fun story you got there. So we're not talking about that.
It's what you posted.
Yeah. So when you go high up in the air, according to this footage, the moon gets really small. And I was just asking, have y'all ever truly thought about it? Isn't that
you know what? It's now your turn.
Interesting.
Go get the picture.
Isn't that because wait, before I go before I go dig through
Go get the picture.
Dude, you don't get to tell me what to do. What world
you don't. Zane, stop it.
I'm trying to explain. For me to find it, I will have to go look through Iru's presentation and find out exactly where it is and then find the link. And I don't care to do that. But I need to know beforehand. You already said you have an excuse for it. So tell me what it is before I show you.
I have a question, though.
What's up?
When you get to it. Well, Zanuck is going to answer you first, right?
Unlikely.
Oh, okay. So you believe both the sun and the moon are local, right?
Relative to what they tell us, yes.
Yeah, relative to what they tell us. Wouldn't getting higher in the atmosphere make it larger, not smaller?
No, because the atmosphere plays a role on what we perceive.
How does it do that?
You're not answering the question.
Yeah.
That would not be the
if you get closer
to be carried through less layers of atmosphere.
Just a minute. If you get closer to something, it gets
well.
larger.
Not whenever it just look. Not if it
smaller.
originally appeared to be larger than it truly was because of the atmosphere.
So that's just begging the question. You're just assuming that.
I'm assuming what? We know that the atmosphere affects how we perceive things.
No, you're assuming that it's already smaller than we see it.
No. What I'm saying is
it's a projection. If it's a projection, it can get larger the further away that you get from it.
That's an assumption.
So, yet again, we'd have to know what this thing is, a projected image or a real object.
Yeah, it's not an assumption, it's a response to your assumption.
No, whether it's a projection
okay, I'll recap for you then.
I'll recap for you.
I'll recap for what you said then, since you're going to lie.
A projection would get larger too, wouldn't it?
That's not what you said. You said when you get closer to the sun and the moon, it would get bigger then, right?
Yeah,
that's your assumption. That's your assumption. No. We countered by saying
geometry.
no.
It's fucking geometry, not assumption. It's geometry.
Why do you have to keep interrupting? We countered by saying what we perceive on the surface of the Earth is relative to the atmosphere. Dun dun dun.
What is that? What is that?
Problem. Trigonometry. It means this.
Worse than that, that's also special pleading, because you're saying that these are the only two objects that follow that.
What are you talking about?
But the thing is, we have two problems here.
Everything else gets larger as you get closer to it.
It seems y'all are having comprehension issues. Maybe Lemon can break it down better.
I am. I'm trying to understand. But you're not explaining that to me.
Lemon do it. Lemon agrees with me on this. We agree. So
two problems. If you're down and away from the moon, you would be peering at it through more atmosphere, up and at an angle, than if you go straight up and look at it straight on. You'd be looking at it through more layers of atmosphere as opposed to straight on at the same layer. Number one. Number two, if it is a projected image, it would get bigger the further you get away from the projected image, and smaller the closer you get to it.
That's not how projected. That's not how projected images.
That's literally
work.
how they work.
No, it isn't. The farther I get away from the movie screen, the smaller the movie screen.
No, my gosh! What you have to do is you look at the movie screen. It's projected at a certain size. You follow it back to what's projecting it, and what's actually projecting it is smaller.
But if I get closer to the movie screen, it gets bigger.
That's not analogous. That's not what we're doing. We're saying, no, I'll say it again. You have it projected onto the wall like a movie theater, right, in your house. You follow the projection back to the projector. The projector is the origin, and it itself is smaller than what was. It is smaller than what was projected.
So you're saying the moon is the projector, not the projected image. So that would mean that the moon is the actual projector. And then the projected image should be where? On the ground somewhere? Where's the projected moon on the ground?
It could be a projected image as well, but you're getting close to the projected image and the projector beyond. It could be projected from beyond the firmament. There's a bunch of different combinations. The main thing is, if you're looking at a projected image, the further you get away from the projector, the bigger the image. The closer you get to the projector, whatever it is, the smaller the image.
Actually, it's really, you can't debate it. I just gave a practical demonstration. You can verify yourself. I've done it before.
Close to the projector gets bigger. If you get closer to the projector gets bigger. So you're fucking talking shit.
my God.
So
We're
talking
about the projection. We're talking about the projection itself.
Get close to a projection. The projection gets bigger as well.
It seems that you're not following. I'll break it down one more time. If you project onto your wall, you have a big TV screen. Okay, now you follow that back to the source of projection. The actual original image that's thus being projected and getting bigger and then hitting your wall is much smaller than the final view on your wall. That's objective.
Bigger and then if you stand closer to that projector, that'll be bigger, won't it?
Put your nose on the.
If it gets closer, the picture will get smaller.
Does the movie look bigger from the balcony or from the first row? Does the movie?
Have y'all not ever used projectors?
Does the movie look bigger from the balcony or from the first row?
All quiet for a second. Winston, I'm walking towards projection. Does the projection get smaller?
The projection. Yes.
Okay, whatever. You're talking about the final projected image on the wall, and you're focusing on that. You're not focusing on the image that is projected through space. Now, if you get closer, you bring that wall closer to the projector, the image projected onto that wall will get smaller.
Y'all strong manning and think it makes you smart. That's so pathetic.
Let me finish this. Lemon, I am not moving the wall. I am moving me. I'm not moving the projector.
You are the wall.
The projection. I am moving me. The moon isn't fucking projected onto me, idiot.
Is it projected onto your eyes? Is it not? Or the camera?
What's it?
There's a little square on the projector. There's a little square. It projects out the image. And then what it actually projects that we see at the end on the wall is much bigger than that little square. You know what we're saying? Please stop straw manning.
Yes.
Let me get this straight. You're saying if I'm walking toward... You literally said if I walk towards the projection gets smaller.
Well, I'm saying the projection itself is smaller the closer it gets to the source, yeah.
So what's it? Your claim is basically that the atmosphere is acting like a screen for a projector that is essentially where the moon is at. Is that it?
Well, yeah, because what we perceive, the light of the moon, it's relative to what it goes through the atmosphere before we perceive it.
But essentially, you're saying the atmosphere is the screen and the moon is essentially projecting onto that screen.
I'm not claiming exactly what's going on with the moon. I just know that what we perceive is relative. That's just, in that hypothetical, sure.
In that,
it doesn't matter either way. My point remains either way.
No, your point is just that. If it's that, if it's the moon projecting itself onto the atmosphere as if a screen.
That's not my point, so please don't straw man me.
Well, what is your point? How does going higher in the sky make the moon get smaller?
Because it's going through less atmosphere, and atmosphere can act as magnification.
But it can't. Excuse me. But it's on a flat surface. We know that you need a curved surface. You need a curved sort of surface to make it lensing. So on a flat Earth, there will be no lensing through the atmosphere because the atmosphere is flat across the surface. Correct?
Sure, but it can act as magnification.
Oh, sure. Yes, thank you. So you just disproved yourself. Thank you.
No, it can act as magnification.
Wait a minute. The lens acts as magnification. You just said, oh, Jesus.
You're telling me that something can't appear to be larger through the atmosphere if the Earth's a ball, if it isn't a ball? You need to sit down, maybe. You need to sit down.
Because lenses happen due to refraction through curved surfaces. Flat surfaces do not make refraction.
No, the refraction has nothing to do with the curved surface of the Earth at all whatsoever. Nothing. Your perception is due to your optical lens. Your perception is relative to optical lens, has nothing to do with the curve of the Earth. What an elementary conflation, and I'm not going to keep listening to it. So
this is their problem. They don't ever try to imagine how to work it on a flat Earth. They just keep thinking.
But it doesn't make any sense. It doesn't.
No, what you're saying doesn't make any sense. To conflate the optical lens, to Earth curve is so stupid.
When you're in an airplane, you're over 75% of the atmosphere is gone, but yet the moon is the same exact size, even though 75% of the atmosphere is gone.
How come when you get way higher than that, it gets smaller?
That's your claim.
That's your claim. You have not proved that claim. Prove that claim.
Yeah,
we deny that claim.
But if we're already through 75% of the atmosphere, why would it be that 75% of the atmosphere has no change, and then the last 25% has some huge change?
The moon is a speck up there.
Because you're peering up and at an angle. That's a diagonal angle, which goes further than straight across. So when you go up,
why is it when the moon is on the horizon to peer through? Why Why is it when the moon is on the horizon and I'm looking through thousands of miles of flat Earth, the moon isn't any bigger or smaller?
It does. They're supermoon. Supermoons. Sometimes it looks bigger.
Supermoon is just a change in size from month to month, depending on whether it's at apogee or perigee.
Oh.
Anyway, why are you talking about this until you provided evidence of the claim? The claim is bogus. Until you
All
provide
your
evidence of
claims
the
are
claim,
bogus,
it's
my
bogus.
friend. You have no evidence for any of the bullshit that you think is real. None of it.
We're talking about.
figured
You've
it out.
raised this question. You've raised this claim about the moon getting smaller as you get higher, and it's bogus
Oh,
claim.
I have to find it, but I know what you're going to say. It just wasn't zoomed in all the way, so y'all are clowns. Y'all are actual clowns.
Well, that obviously is the fucking answer. What how can you just
Well, but
dismiss
this
that
is
as
why
an
it
answer?
doesn't answer the question. Because the sun is also in the frame, and it's way bigger.
And we're all projecting our own images. We don't see each other's images.
The
We
moon
just
looks
see
like
our
a
own.
star,
That's
and
why
the
you
sun
get
is a
close to the moon, it gets
huge.
Because the sun is a lot brighter. You cretin.
Yeah, I know that. I know that. That's why I said I needed a solar filter when I prefaced this entire introduction.
Well, then if you don't have evidence with a solar filter, you don't have fucking evidence, do you?
Well,
If
we're
you
talking about the
present
moon
evidence that
appears
doesn't have
very,
a solar
very
filter,
small when you get up high.
If you look up
it
solar
does not appear small when you get
high
up high.
altitude, you see the little black dot in front of the sun, and that's not really just explainable on y'all's model. I don't think so.
Hey, when I'm just standing outside with no optical aid and I look up, the moon looks pretty big. When you go way high up with no optical aid, it gets way, way smaller.
Have you been up high?
Seen the footage.
You've seen the footage, but there's an optical aid, isn't it? What was the footage taken with, you cretin? Of course it was taken with a camera. That's an optical aid.
Yeah, of course. But what I'm saying is it's not zoomed in, so that just kind of attacks your whole,
How do you
we
know
just can't zoom in enough. No, what?
Try and do it without the
you,
name calling, guys. Try and not call each other names. Try not to do that.
My bad.
No worries, mate. Thank you.
So, but do you have the information on the zoom level of the camera? Do you have the focal length?
I have to try to
data? Do you have,
find
like,
it.
the
I
exit
already
data?
said I'll have to dig through to find all of it. That's why I just brought it up casually. I said I would, though, because I don't care to, because I'm not the one that has some emotional bias
You
here.
said you won't. You can't be bothered. I heard you say you can't be bothered.
What? No, I'm saying I have to go dig through all of it. I said I would, but no, I'm not going to just do it right now. What?
You're not going to.
I didn't say I wouldn't.
It's a bogus
I
claim.
probably won't do it for you
Yeah,
because you're a
can we
clown.
move-
You think
can
I
we
just
move
made
off
that
the
up?
bogus
You
claim
think I just
point?
made it up? Wait,
It's a
so you
bogus
actually think I
claim
made it up? We
I
were
believe
live
that-
broadcasting when I first saw it, you clown. I don't even know what you're talking about. You just talk. That's what you do. So anyway, can we move
I
on?
believe the footage exists, but there's no comparison between the footage at a low with the same camera at a low height. This is easy evidence to collect. You take footage from a low height with the same camera.
Yeah,
at
it was
same
on the
settings,
whole
you take
time, so we'll
footage from
show
a
you. I'll
high
show
height.
you. I'll show you. Yep. And you'll feel like an idiot, but you won't admit it. So next.
There is a super chat I have to read out, which says, he's a moron. Thank you very much, Todd Allen, for that. I'm not sure who you meant by that.
I think we have an idea.
But
Very
that's
creative.
what the super chat said, anyway.
So, all right, I've been in here for a while.
Hey, listen, really quick. Can you welcome me to Flat Earth, please? I just want to hear it.
No. But yeah,
give me
okay,
the
I will.
welcome to Flat Earth,
Okay. If the surface, listen. If the surface of the Earth isn't curving anywhere, then what is it?
I just posted something going back a little bit. Your desire.
Wait, real fast. If the surface of the Earth isn't curving anywhere, what is it?
If it's not curving, it can be flat. There's only two options.
Welcome to Flat Earth. All right, I'll catch up with y'all later.
You got your picture. I got your picture. It talks about
square.
I got the Maritime Organization from San Francisco to talk all about this in a whole chapter. And there's your information. Now you can look at it and deny it, but this is coming from some reputable sources.
Hey, is the
It shows
horizon an actual or an apparent location?
Oh boy.
Yeah. Just look at this. It has the horizontal.
I saved it. I saved it, dude.
Hold on. It has the horizontal compared with line of sight, and it talks about the projections and the corrections for Earth curvature. This is exactly what you wanted, and you're not going to obfuscate and get out of it.
No, I already
Read it.
saved
You
it,
can-
and I'm going to
hold
look
on,
at the
hold on,
documents themselves in a
hold
little
on,
bit,
hold on.
and I'll
I'm
also
talking,
bring back
I'm
that up.
talking. Hey.
Oh my God, I'm
Listen,
leaving though,
you
Zanuck. I
can
don't
leave
give a
all you
shit.
want, but I gave you what you wanted. I dug through it. I found one thing I wanted to show you, and I have the link too.
Okay, you sent screenshots about rotation, and then you sent the screenshot. I saved it.
No, this is the one you wanted.
Cool, thank you, man. I saved it. Thank you.
There
Okay,
you go.
I'll also look at the document, and then I'll try to remember.
And
to
I can
bring
give you the
back
document too if you'd like.
I will bring back the footage I was discussing.
But read
Okay.
this, and I'll give you the document.
Is there a difference in an appearance and an actual location? Wait. Is the horizon
your story straight.
an apparent is the horizon an apparent location? Yeah, it's very simple. Listen. Is the horizon an appearance or an actual location? Is the horizon apparent or actual location?
Answer the question.
There are actual locations, geometric as well.
Oh, can you just answer the question? Is the horizon that we see actual or apparent?
They are not the same. They are not the same. There's always a margin of error in every measurement you will ever take.
Okay, is the horizon we see actual or apparent?
It's always going to be apparent.
Welcome to Flat Earth. All right, I'll catch up with y'all later.
Also, you don't seem to understand. Any apparent horizon is an optical view of a physical location.
That's what you say.
Are you telling me that at the horizon there's no locality?
Oh
there,
well, sure.
regardless of how it's reflected to you?
Well, the horizon itself has no physicality, no. But sure, it is about. It's a reflection of. It's a reflection of physical world. Yeah, of course. So anyway.
I got the website for you.
Welcome to Flat Earth, dude.
Then
there's no duality. Then there's no split. Yes, no, according to the way you're doing it.
Okay, so there's.
Set up a flawed question.
No, actually, it's a very simple question. The horizon is just the horizon's an apparent location, so it cannot be equated or conflated to being physical evidence of a physical location of a geometric horizon.
Not go to that location?
That's subjective. Welcome to Flat Earth.
Can a person not go to the location that is being reflected optically?
No, of course not.
See that cruise ship that's been in the chat there. Can you not, if that cruise ship stopped, could I not catch up to it?
Yeah, but could you catch up to the apparent location where the sky appears to meet the ground and touch it?
Yes. Yeah, that's
someone just said yes. Okay, well there you go, guys. So either you just completely go against all logical deduction, you behave counterintuitively, defending the liars that told you where you live as if they retained you as a defense attorney.
Is the boat an apparent boat? Is it an illusion? Does it not exist?
I did not make the Earth. I did not tell you what the Earth was. We went and tested it. It's a geocentric stationary plane. There's no Earth curvature. An apparent location of a horizon is not a physical horizon.
Go in peace, my friend.
My friend, I know it's uncomfortable for some people to entertain it, but take it or leave it. Okay, well, make sure that you really understand that apparent. I have no idea how apparent locations are not the same as actual locations. It's very simple. So you cannot get physical, empirical evidence of a physical location from an apparent location inherently. It's just impossible. It's a futile pursuit destined to oblivion. Welcome to Flat Earth.
You don't understand.
Okay, well, you have fun with that.
All right, bye. Let's see, bye with it. Have fun. What?
Man, unbelievable. Denial runs deep in this young man.
Unbelievable. We had 50.
You're coming from a person who says that the second law of the second law ain't entropy, and I look it up and it's called the entropy law. How can I believe anything that Xanax says after that?
Because is the entropy law the law of entropy? They call it affectionately.
Case closed. Right.
That's my point. They call it affectionately the entropy law. It's not the law of entropy. There is no law of entropy. Entropy is a property, a thermodynamic property of the second law. Do you know the difference? Do I have to explain it to you?
It takes a special kind of stupid to
Are you
be able to
listening to
recite
yourself?
that without
Are
even
you listening to
any
yourself?
basic understanding of
Are you
of
listening?
words.
It's not the entropy law.
Let's
That's just a name of something. It's not actually what it is. It's not a law of entropy. There's no such thing. It is a thermodynamic property of the second law. Does that make sense?
Yes. Let's not get too semantic. The thing is, the
It's
railroad
not semantics. There's laws and then there's properties of the laws. Entropy is not a law.
The railroad tracks appear to ramp
Not
up
a
to eye level. They're not
It's not a
physically
conserved
doing that.
quantity.
There's no physical thing to go with the railroad tracks that are ramping up toward horizon. If you shoot a laser to that location, it will shoot over the railroad tracks.
Level.
That's by the law of perspective. Don't deny perspective.
They don't come up to eye level. That's demonstrable.
They ramp up toward eye level.
But they don't
Because
ever
you're
get
because you're looking at a tangent.
It's not a physical meeting of Earth and sky per se, where you can shoot a laser to that location and it'll hit it as it's ramping up. It's just a 2D visual representation in your eyes.
They got to deny basic reality for their argument.
Well, here's a dose of reality after 500 years of Jesuit sophistry.
Literally, the only people who have provided sophistry on the issue are flat earthers who intentionally use fallacious arguments and make misleading comments and go out of their way to misrepresent everything. Y'all, by definition, engage in the most basic forms of sophistry every time you come up with anything.
I particularly like the claim that things get smaller as we get closer to them. That was a touch of pure genius.
I like how that was. You know what, Don, you're right. That was with the observer.
That was amazing.
I went investigating that. I looked at about the highest footage I could really get, and I come across the Felix Baumgartner, and they show the horizon from the ground level outside the capsule. That
really
line
robotic,
up to
pretty bad.
128,000 feet. Oh yeah, let me try and get a better connection.
Man, there's some nasty denial going on here. Unbelievable.
It would get smaller if it was a projection.
Is that any better?
No.
Oh yeah. It would get smaller if it was a projection. Your eyes would be the thing that the image is projected onto, and/or the camera.
So what Witsit did is something that no sane person would ever say. That's how we can know that at that moment he was simply bullshitting. That's just pure deceit.
Lemon, it does not matter which direction I am walking. If I walk towards the projection, it'll get bigger in my sight. If I walk towards the projector and I'm looking at where it's at the source where it's being projected from, that source will appear to get bigger in my sight.
But if your eyes are the wall that the thing's being projected onto, potentially as you get closer to the projector, the image would diminish in size.
Lemon, walk towards
images are focused.
Walk towards the projector, yes. Lemon, and you will see that the projection from its source, as you get closer to it, still appears to get bigger. When you're walking towards the projector, when you're walking towards the projector, where the light is coming out from, it gets bigger, and you see the picture. It's more out of focus, but it's still bigger.
What about a laser beam, like a laser from 500? My little pointer laser from about 500 feet away. It
give a
gives
fuck less about your laser.
I'm just giving you an example of where
you're
not always right.
Smaller as you get closer.
Brian, with your little, Mr. Leakey, with your hand laser at 500 feet, I'm looking at a cone that's approximately 10 meters wide.
Just giving you an example where you're not always correct.
The image would get smaller.
No, that's not an example of that.
So it is. Apply the example to the problem. As you get closer to the laser, it would get smaller.
That's wrong. That's wrong.
I think the part that you guys are missing is that
solution to the problem.
That's wrong.
What you guys are missing
that's an argument from bureaucracy. You don't want to apply the solution to the problem because you're getting paid not to understand, or you just don't like the solution.
No, what you guys are missing is that your pupil has a fixed size. Your pupil has a fixed size, so if something is projecting onto your pupil, there's going to be less light the further you get away from it, and the closer you get, more light will hit your pupil.
Your pupil does not.
Pupils are not a fixed size.
Unlike a projection screen that has lots of area to absorb a bigger or a smaller projection, your eye is always the same size. So,
well, Lemon is just confusing the projector with the projection.
Well, if you get closer to the projector, yeah, it would be.
That's not the question. That's not the question. If the moon is the moon is the projection, not the projector.
Okay, so if you get closer to the projected image, potentially, if your eyes are the wall, perhaps it gets smaller the closer you get to it.
Lemon. Does the movie look bigger from the balcony or from the first row?
from the first row, but you're talking about the projected image on
No.
the wall. Your eyes are the wall
Yes.
in this analogy.
Yeah.
No,
and,
no,
hold
our
on.
eyes are not the wall.
So it would be
Brenda,
like
here's an
bringing
easy.
the wall
Brenda, here's an
closer to the
easy way to get him though.
projector. It would be
Here's an
like
easy way to
bringing
get
the
him. Here's the,
wall- It would be like bringing the wall
Lemon.
closer to the projector.
hold on, Lemon. Let's say I go to the movie theater and I go right up to the screen and I do a 180, and now I'm staring at the projector in the face, right? What I'm going to see is I'm going to see a very bright light somewhere in my field of view, right? And as I walk towards that bright of light, that bright light, that light will start to get brighter and bigger and brighter and bigger up until I have my eye directly in front of the projector and I can't see anything because all I have is a bright light in my eye, like a flashlight in my eye. But when I'm standing right in front of the screen, it's just a tiny dot amongst a black background. Right?
But you still got the example that Brian was talking about where it's a big dispersed thing of light from far away. You get closer to it, the light gets smaller and smaller and more focused. So it's
we're talking about the projection, not the projector. You're getting confused again.
Your eyes are the wall that the image is being projected onto.
No, my eyes are not the wall.
Projector, bring your eyes closer to the moon.
My eyes are not the wall.
Try and let him give a
Lemon, wait. Lemon, if we use your example, and my eyes are the projection, and my eyes are the projector screen, that means I'm within the beam the whole time. As I get closer, it'll take up more of the total vision, and it'll just be a big white dot. It will get bigger as I get closer to it. You are still entirely fucking.
Nah, you're going through different layers of atmosphere, different electrical fields and stuff like that as you get higher up. Perhaps this is
different
working,
layers
and
of
we need to look at
atmosphere
this from a
don't
different
change anything.
perspective.
You have to have changes in density, and the density is the most closest to the surface of the Earth.
Well, the sky appears to be bluer closer to the ground, but as you get higher up, it's black under the firmament. So it looks like there's something different.
So did you guys realize that Lemon just went, oh, yeah, I get it now, and radically changed the topic?
Yes, you have to do that to power through BS, Mr. Mackey. Because
that's
the
not
Globers
BS.
are full of
That's you denial.
And obscurantists who would rather skate around the truth for the lie than get straight to the heart of the issue. This is a key strategy, Mr. Mackey, to peer through the BS.
Wow.
That's just denialism. That's
ultimate bullshit.
Projection, pun intended.
Oh, okay.
But thanks for admitting your strategy there, Lemon. Just a moment of clarity, a moment of brutal honesty. I do bullshit to change the subject.
Yeah,
that's the only way you can cope with the truth. That's you're admitting your technique. Well done, thanks.
So you deliberately mislead in order to maintain your belief, right?
Where have I misled anyone?
I guess when that doesn't work, you just shut down. Right?
I didn't mislead anyone. I mean, I explained earlier on. I explained earlier on that when you get closer to the projector is going to get larger. That's not misleading anyone. And you've just realised that's true, right? Because you quickly changed the subject.
We're talking to Lemon.
Yeah.
Yeah. Lemon EXE has thrown an exception and has had to kill screen.
Lemon's left.
Wow, he got caught, thought about it,
yeah,
tried to change the subject, got called on it, and fucking ran.